Sejalan dengan tujuan negara Republik Indonesia dalam mencerdaskan kehidupan bangsa, Sekolah Tinggi Keguruan dan Ilmu Pendidikan STKIP PGRI Sumatera Barat hadir dengan semangat dan moto mencerahkan dan menginspirasi anak bangsa. Dengan berbagai transformasinya, semenjak berdiri tahun 1984, STKIP PGRI Sumatera Barat maju sebagai lembaga pendidikan tinggi yang membukakan cakrawala dunia melalui ilmu pengetahuan dan pendidikan, serta memiliki posisi penting dalam perkembangan pendidikan di Indonesia, khususnya di Sumatera Barat. Terletak di Jalan Gunung Pangilun, Kota Padang, STKIP PGRI Sumatera Barat memiliki lokasi yang strategis karena berlokasi di pusat ibu kota Provinsi Sumatera Barat. Kampus STKIP PGRI Sumatera Barat berdiri kokoh di atas tanah seluas 26.890 meter persegi yang membentuk struktur dan suasana yang kondusif untuk menjalankan proses pembelajaran dan pendidikan. Berdiri dan berkembang bersama masyarakat, terus bergerak dan terus membangun bangsa, STKIP PGRI Sumatera Barat bertekad untuk menjadikan perguruan tinggi unggul di bidang keguruan dan ilmu pendidikan yang kompetitif di wilayah Sumatera tahun 2026. Dengan tekad tersebut, STKIP PGRI Sumatera Barat berkomitmen melaksanakan pendidikan dan pengajaran yang berbasis kepada pengembangan kecerdasan intelektual, hard skills, dan kecerdasan emosional, soft skill, untuk memperoleh kecakapan hidup, life skill. Melaksanakan dan mengembangkan penelitian dan pengabdian di bidang pendidikan dan pengajaran, serta bidang lain sesuai dengan keilmuan program studi, mengembangkan ilmu pengetahuan, teknologi, dan seni, ipteks yang dilandasi profesionalisme. Menyelenggarakan perguruan tinggi yang akuntabel, efisien, efektif, transparan, relevan, dan mandiri, serta mengembangkan kerjasama dengan berbagai lembaga terkait dan stakeholders untuk berkelanjutan pelaksanaan program atau pembukaan program studi baru. Saat ini STKIP PGRI Sumatera Barat memiliki program-program studi dengan akreditasi B. Dengan berkomitmen pada pembentukan karakter lulusan yang berkualitas, STKIP PGRI Sumatera Barat menempa mahasiswa yang berbasis pada kompetensi utama, yaitu kompetensi pedagogik, kompetensi profesional, kompetensi sosial, dan kompetensi personal yang unggul di bidang pendidikan. Sebagai kompetensi penunjang, di STKIP PGRI Sumatera Barat, mahasiswa dibina dan dilatih tidak hanya menjadi calon pendidik, tetapi juga sebagai insan yang memiliki kecakapan hidup, life skill. Dengan hal ini, terbukti banyak lulusan STKIP PGRI Sumatera Barat telah bekerja di berbagai lini, baik di dalam maupun di luar negeri. Mahasiswa STKIP PGRI Sumatera Barat adalah mahasiswa yang penuh dengan semangat dan kreativitas. Banyak prestasi yang telah mereka ukir, baik berskala nasional maupun internasional.
STKIP PGRI Sumatera Barat selalu mendorong mahasiswanya untuk berprestasi di berbagai bidang. Saat ini saya telah meraih medali emas pada Porprov Sumbar 2016. Hal tersebut tidak terlepas dari dorongan dan dukungan kampus.
Dulu saya mengira kuliah di STK PGRI hanya mengajarkan menjadi seorang guru. Ternyata banyak keahlian-keahlian lain yang bisa saya dapatkan di sini. Seperti halnya saya bersama STK PGRI Sumatera Barat mendapatkan hibah dari program kreativitas mahasiswa tahun 2016 dan alhamdulillah pada saat sekarang ini saya telah berhasil menjadi wirausahaan muda.
Saya finalis Putri Kampus Sumatera Barat 2016.
Saya Uni Talenta Kabupaten Solok Selatan 2016.
Kami senang dan bangga kuliah di STKIP PGRI Sumatera Barat.
Selain di bidang akademik, kami juga bisa mengembangkan potensi diri kami di bidang non-akademik lainnya.
Sebagai lembaga pendidikan tinggi terkemuka di Kopertis Wilayah 10, Sumbar, Riau, Jambi, Riau Kepulauan, dan terperingkat di Indonesia, STKIP PGRI Sumatera Barat mengambil langkah kerjasama dalam peningkatan proses kegiatan belajar dan pengembangan pendidikan. Kerjasama itu dilakukan dengan lembaga maupun institusi dalam negeri dan di luar negeri. Kerjasama luar negeri telah dilakukan dengan berbagai lembaga di kawasan Asia, Eropa, dan Australia. Dirancang untuk menjadi perguruan tinggi kelas dunia yang berbasis kepada Research University, saat ini STKIP PGRI Sumatera Barat adalah satu-satunya sekolah tinggi dengan klaster utama dalam bidang penelitian di Indonesia. Di samping itu, beberapa tahun terakhir, pemerintah Jerman telah mengirimkan mahasiswa magang untuk melakukan penelitian bersama dosen-dosen STKIP PGRI Sumatera Barat.
Saya Dr. Haji Dasrizal MB, Ketua Pengurus Badan Pelaksana Harian STKIP PGRI Sumatera Barat, terus mendorong dan menopang visi dan misi Ketua STKIP PGRI Sumatera Barat dalam pelaksanaan kampus, termasuk juga dalam rangka perubahan bentuk menjadi Universitas PGRI Sumatera Barat, mulai dari pendidikan, pengajaran, pengabdian, dan pengembangan sarana prasarana, tentu menjadi tanggung jawab daripada BPH ke depannya sehingga dapat menjadi universitas yang dibanggakan dan menjadi entrepreneur university pada tahun 2026.
Kami yakin semua upaya yang telah dilakukan adalah sebagai bentuk komitmen kami untuk menjadikan STKIP PGRI Sumatera Barat menjadi kampus yang mampu melahirkan lulusan yang berkualitas, unggul dan kompetitif.
Jika ingin menjadi pendidik profesional yang mencerahkan dan menginspirasi anak bangsa, disinilah tempatnya.
Mari rayakan Putra Putri Bapak dan Ibu kuliah di STKIP PGRI Sumatera Barat.
Guna mewujudkan lulusan profesional dan berkarakter, sebagai wakil ketua 3 bidang kemahasiswaan, alumni dan kerjasama, berbagai upaya telah kami lakukan hingga sejumlah prestasi telah diraih oleh mahasiswa kita di STKIP PGRI Sumatera Barat.
Di STKIP PGRI Sumatera Barat, intelektualitas diri ditanamkan. Di STKIP PGRI Sumatera Barat pula, semua integritas disematkan. Melalui kasih sayang, STKIP PGRI Sumatera Barat bangkitkan sikap kemandirian. Dengan semangat kemajuan, STKIP PGRI Sumatera Barat kuatkan sebuah daya juang. STKIP PGRI Sumatera Barat siap menciptakan pemimpin yang akan menaklukkan masa depan.
Program studi pendidikan matematika adalah salah satu program studi dari 14 program studi yang ada di STKIP PGRI Sumatera Barat. STKIP PGRI Sumatera Barat adalah kampus yang mencerahkan dan menginspirasi anak bangsa. Lulusan program studi pendidikan matematika mampu bersaing secara nasional dalam mendapatkan pekerjaan. Dengan bukti, pada penerimaan CPNS pada tahun ini, lebih dari 40 orang lulusan program studi pendidikan matematika diterima di Dinas Pendidikan Kemenak pemerintah kota, baik di Sumatera, Riau, Batam, dan Pulau Jawa.
Program studi matematika kita sudah mempunyai 25 orang dosen, yang mana itu 100% kita sudah dosen sudah bersertifikasi. 2 orang berkualifikasi dokter dan 4 orang lainnya itu sudah melanjutkan studi S3 di kampus-kampus ternama baik di dalam maupun di luar negeri. Dan untuk kegiatan program studi pendidikan matematika yang dapat mengembangkan diri baik dosen dan mahasiswa, kita sudah banyak melaksanakan kegiatan. Yang pertama yaitu melakukan seminar nasional dari tahun 2015 sampai dengan saat sekarang ini. Dan dari pihak kampus pun kita juga sudah melaksanakan studi banding, yaitu ke ICoMMΣd yaitu di Taiwan, yang mana sudah mengirimkan 1 orang dosen dan 1 orang mahasiswa yang sudah terpilih. Alumni program studi pendidikan matematika telah tersebar di berbagai instansi, di antaranya BUMN, BUMD, Diknas, serta perusahaan ternama lainnya.
Prodi menggunakan aplikasi untuk mempermudah dalam perhitungan matematika. Hadapilah semua dengan cinta.
Ada juga kegiatan senior mementori junior dalam belajar matematika.
Dari program studi pendidikan matematika juga mempunyai pengurusan yang disebut Himatika. Himatika sendiri juga memiliki program kerja unggulan seperti LOSEMA, Lomba dan Seminar Matematika. Lombanya tingkat SLTA dan Seminar Matematika. Ada juga Aksioma, ajang kompetensi seni dan olahraga matematika, dan lombanya Domino Matematika, tingkat perguruan tinggi. Selanjutnya Lopedia, lomba dan pameran media pembelajaran matematika.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Selamat pagi dan selamat datang kepada Bapak, Ibu, dan hadirin yang kami hormati. First and foremost, let us pray and praise to Allah Subhanahu wa Ta'ala. Because of His blessing and mercy, we can come together without any obstacle here with healthy condition in the International Conference on Mathematics and Mathematics Education, ICoMMSd 2021 of the Mathematics Education Department, STKIP PGRI Sumatera Barat, with technology application in evaluating mathematics learning during the pandemic era. Thursday, October 28th, 2021. Pertama dan utama sekali, mari kita ucapkan puji dan syukur kehadirat Allah Subhanahu wa Ta'ala yang telah memberikan rahmat dan karunia kepada kita semua sehingga kita dapat berkumpul dalam acara International Conference on Mathematics and Mathematics Education ICoMMSd 2021 Program Studi Pendidikan Matematika STKIP PGRI Sumatera Barat dengan tema Technology Application in Evaluating Mathematics Learning during the pandemic era, Kamis 28 Oktober 2021. Second, let us greet and pray to our beloved Prophet Muhammad sallallahu alaihi wasallam, who had brought us to the path of light and left the darkness in this life. Salawat beserta salam kita ucapkan kepada Nabi besar Muhammad Sallallahu Alaihi Wasallam yang telah membawa umatnya dari alam yang penuh dengan kebodohan ke alam yang berilmu pengetahuan seperti saat sekarang ini.
The Honorable Profesor Dr. Ansofino MSI as a President of STKIP PGRI Sumatera Barat.
Yang terhormat Ketua STKIP PGRI Sumatera Barat, Bapak Profesor Dr. Ansofino MSI.
The Honorable Mrs. Sri Inawati MPD PhD, Mrs. Liza Husnita MPD, Mr. Jarudin MA PhD as Vice President of STKIP PGRI Sumatera Barat.
Wakil Ketua Bidang Akademik Ibu Sri Inawati MPD PhD, Wakil Ketua Bidang Administrasi Umum dan Keuangan, Ibu Liza Husnita, MPD. Wakil Ketua Bidang Kemahasiswaan, Alumni dan Kerjasama, Bapak Jarudin MA, PhD.
The Honorable Mrs. Dr. Anda Rahmi, MSc, as Chairperson of Mathematics Education Department.
Ketua Program Studi Pendidikan Matematika, Ibu Dr. Anda Rahmi, MSI.
The Honorable Mrs. Yulia Haryono, MSc, MPD, as a Vice Chairperson of the Mathematics Education Department.
Sekretaris Program Studi Pendidikan Matematika, Ibu Yulia Haryono, SSI, MPD.
The Honorable Professor Wanti Wijaya from Deakin University, Australia. Mr. Nathanael Karyanto, PhD, from Sungkyun Kwan University, Republic of Korea. Dr. Ismail Raab from Fatani University, Thailand. Dr. Anwar bin Moh Yusuf from University Kelantan, Malaysia. Dr. Delsi Kariman, MSc, from STKIP PGRI Sumatera Barat, Indonesia, as our keynote speakers today.
Yang kami hormati narasumber Seminar Internasional Program Studi Pendidikan Matematika STKIP PGRI Sumatera Barat, Ibu Profesor Wanti Wijaya dari Universitas Deakin, Australia, Bapak Nathanael Karyanto, PhD dari Universitas Sungkyun Kwan, Republik Korea, Bapak Dr. Ismail Raab dari Universitas Fatoni, Thailand, Bapak Dr. Anwar bin Moh Yusuf dari Universitas Kelantan, Malaysia, Ibu Dr. Delsi Kariman, MSI dari STKIP PGRI Sumatera Barat, Indonesia, yang pada saat ini sudah hadir pada Zoom meeting.
The Honorable all of the participants and presenter of this conference today.
Dan yang teristimewa kepada seluruh peserta dan pemakalah yang hadir pada acara hari ini.
Ladies and gentlemen, Indonesia's national anthem, Indonesia Raya.
Hadirin yang berbahagia, mari sama-sama kita dengarkan lagu kebangsaan Indonesia Raya.
Now, with a great honor, we would like to invite Mr. Jarudin MA PhD as the Vice President of STKIP PGRI Sumatera Barat to deliver welcoming speech and to open this conference officially. Ladies and gentlemen, please welcome Mr. Jarudin MA PhD.
Sambutan Wakil Ketua Bidang Kemahasiswaan, Alumni dan Kerjasama, Bapak Jarudin MA PhD, sekaligus membuka acara secara resmi International Conference on Mathematics and Mathematics Education ICoM 2021, Program Studi Pendidikan Matematika STKIP PGRI Sumatera Barat. Kepada Bapak, disilakan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah wa syukurillah, ashhadu an la ilaha illallah wa ashhadu anna Muhammadan abduhu wa rasuluh la nabiyya ba'dah. Yang kita hormati Ketua BPH STKIP PGRI Sumatera Barat dan SMA 1 PGRI Padang, Bapak Dr. Dasrizal MP. Seterusnya yang kita hormati Ketua STKIP PGRI Sumatera Barat, Bapak Profesor Dr. Haji Ansopino MSI, beserta Wakil Ketua 1 dan Wakil Ketua 2. Seterusnya yang kita hormati Ibu Pimpinan Program Studi Pendidikan Matematika, Ibu Dra Hajah Rahmi MSI, beserta Ibu Sekretaris. Seterusnya yang kita hormati dan kita banggakan semua panitia pelaksana konferensi yang sudah bekerja keras mempersiapkan kegiatan ini dengan sebaik-baiknya sehingga pada kesempatan pagi hari yang berbahagia ini bisa kita laksanakan dan insya Allah bisa sukses sampai akhir kegiatan nanti. Dan teristimewa kita ucapkan terima kasih penghargaan yang setinggi-tingginya kepada keynote speaker kita, narasumber pada kegiatan konferensi ini yang sudah hadir di talian Zoom. Terima kasih kepada para pemateri. Ada Ibu Nathaniel Karjanto PhD, Bapak Nathaniel Karjanto PhD, Profesor Wanti Wijaya, Dr. Ismail Raup, Dr. Anwar Muhammad Yusuf, dan Ibu Dr. Delsika MSI. Terima kasih, selamat datang kami ucapkan di kampus STKIP PGRI Sumatera Barat, kampus yang mencerahkan dan menginspirasi anak bangsa.
First of all, let us grateful to Allah Subhanahu wa Ta'ala who has given healthy and gathering today in this conference. And we also pray for our Prophet Muhammad Sallallahu Alaihi Wasallam who has brought people from the dark to brightest. The Honorable Founder of STKIP PGRI Sumatra, Bapak Mr. Dasrizal MP, and then the Honorable Vice President STKIP PGRI Sumatra, Ms. Sri Ilmawati PhD, Ms. Liza Husnita, and the Honorable Chairperson of Mathematics Education Department, Ms. Dra Rahmi MSI, and then the Honorable Vice Mathematics Education Department. And we are proud to announce and welcome for all keynote speakers, for the Professor Wanti Wijaya, Professor Nathaniel Karjanto, and then Mr. Anwar bin Muhammad Yusuf Muhammad, Dr. Ismail Raub and Delsika MSI.
Alhamdulillah Bapak Ibu semuanya, kegiatan konferensi ini merupakan agenda rutin yang dilaksanakan oleh program studi khususnya di program studi Pendidikan Matematika. Ini salah satu bentuk keseriusan kita di STKIP PGRI Sumatera Barat untuk meningkatkan kualitas daripada kampus, baik dari segi dosen juga dari segi mahasiswanya. Kegiatan ini kita harapkan ke depannya bisa berlanjut dan bisa kita laksanakan dengan peserta yang lebih banyak lagi dalam rangka berbagi ilmu dan berbagi pengalaman dalam rangka untuk meningkatkan SDM kita semuanya.
This is our routine activity for every years, and we hope that this international conference can be get a lot of knowledge, and we can share our research to other people.
Mungkin tidak banyak yang dapat kami sampaikan pada kesempatan ini. Dengan mengucapkan basmalah, kegiatan konferensi program pendidikan matematika STKIP PGRI Sumatera Barat secara resmi kita buka.
That's all the opening ceremony from us, and then thank you for your attendance, and we officially will Professor Mr. Jarudin open this international conference.
Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Thank you to Mr. Jarudin MA PhD as the Vice President of STKIP PGRI Sumatera Barat for welcoming speech and opening this conference.
Terima kasih kami ucapkan kepada Bapak Jarudin MA PhD.
The last is closing and prayer. The prayer who will be recited by Mr. Radia Yusri MPD. To Mr. Radia Yusri MPD, stage is yours.
Pembacaan doa oleh Bapak Radia Yusri MPD. Kepada Bapak disilakan.
Assalamualaikum warahmatullahi wabarakatuh. Na'udzubillahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin wal aqibatu lil muttaqin. Wassalatu wassalamu ala asrafil anbiya'i wal mursalin wa ala alihi wa ashabihi rasulillahi ajma'in. Ya Allah, kami agungkan namamu karena hanya Engkaulah Tuhan kami, Tuhan yang maha kuasa atas segala sesuatu. Pada hari ini ya Rabb, jiwa dan raga kami serahkan semata-mata mengharap ridha dan rahmat-Mu. Oleh karena itu, wahai Allah, lancarkanlah acara kami. Berkahi dan penuhilah kegiatan ini sehingga membawa rahmat dan barakah di sisi-Mu. Ya Allah, Tuhan yang maha pemurah, bukakanlah pikiran kami, sucikan hati dan jiwa kami. Karuniakanlah kepada kami ilmu yang bermanfaat, dan berilah kami kemudahan untuk memahami dan mengamalkannya. Janganlah Engkau bebankan kepada kami beban yang tak sanggup kami untuk memikulnya. Ya Allah, Tuhan yang maha pengasih, maha suci Engkau atas segala ketetapan dan takdir yang kami rasakan dalam hidup ini. Berikanlah kami hidayah untuk selalu dekat denganmu dalam beribadah. Jadikan kami umat yang mampu bersabar atas segala ketetapan-Mu, serta mudahkanlah langkah kami untuk selalu menuntut ilmu dan berbuat baik bagi sesama. Allahumma inna nas'aluka ilman nafi'an wa amalan mutaqabbalan wa rizqan halalan thayyiban mubarakan fi. Allahumma bika asbahna wa bika amsayna wa bika nahya wa bika namut wa ilaikan nusur. Ya Allah, Tuhan yang maha menyatukan, tautkanlah tali persaudaraan dan tali kasih di antara kami, sehingga kami dapat menyikapi apapun perbedaan dengan indah. Jadikanlah acara ini sebagai simbol kebersamaan, simbol kekuatan, dan persatuan untuk membangun negeri tercinta ini. Ya Allah yang maha pengampun, kami sadar ya Allah, tak sedetik pun kami bebas dari dosa dan kesalahan, dan tak sejengkal pun di hati kami yang bebas dari kesombongan, kealpaan, dan keinaan. Melalui sifat-Mu yang Ghafur ya Allah, ampunilah segala kesalahan kami, kejahilan kami, sikap kami yang melampaui batas dalam urusan kami, dan segala hal yang Engkau ketahui dari diri kami. Sesungguhnya Engkaulah yang maha pengampun, lagi maha penyayang. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Thanks to Mr. Radia Yusri MPD. May the prayers can be answered by Allah Subhanahu wa Ta'ala. Amin.
Terima kasih kami ucapkan kepada Bapak Radia Yusri MPD.
Finally, we apologize for all the shortcomings in presenting this opening ceremony of the International Conference on Mathematics and Mathematics Education, ICoM 2021, and thank you for your kind attention.
Demikianlah acara pembukaan International Conference on Mathematics and Mathematics Education ICoM 2021, Program Studi Pendidikan Matematika STKIP PGRI Sumatera.
The next is a video from student community of Mathematics Education Department STKIP PGRI Sumatera Barat.
Penampilan selanjutnya, tari kreasi dari Sanggar Tari Program Studi Pendidikan Matematika yang pernah ditampilkan pada seminar nasional sebelum pandemi. Penampilan tari kreasi dari Sanggar Tari Program Studi Pendidikan Matematika yang pernah ditampilkan pada seminar nasional sebelum
Prodi of Mathematics Education Department.
Itulah penampilan dari Sanggar Tari Program Studi Pendidikan Matematika STKIP PGRI Sumatera Barat.
The second video, our dedicated to my beloved friends on Mathematics Education Department and all of participant and presenter. Check this out.
Video selanjutnya merupakan video dedikasi dari program studi matematika untuk semua peserta International Conference of Mathematics ICoM 2021. Silakan menyaksikan.
Ku tengadahkan wajah, tatap ini tercurah, mengintai gerak awan putih, jantung ini mendidih. Hanya ada satu cerita untuk masa depan, bahwa kita takkan mengalah meski hidup taruhannya. Cinta menghentikan takut, berganti jadi patuh. Jiwa raga pun tak surut, perjuangan tak luput. Hanya ada satu cerita untuk masa depan, bahwa kita takkan mengalah meski hidup taruhannya. Cinta negeri mengalahkan segala, tak satu pun jadi kendala. Biar nafas hanya separuh, tak rela ku mengadu. Membawa terbang menembus kawan, berlapis langit berjalinan. Separuh nafas berarakan, siap demi baktiku pertiwi. Cinta menghentikan takut, berganti jadi patuh. Jiwa raga pun tak surut, perjuangan tak luput. Hanya ada satu cerita untuk masa depan, bahwa kita takkan mengalah meski hidup taruhannya. Cinta negeri mengalahkan segala, tak satu pun jadi kendala. Biar nafas hanya separuh, tak rela ku mengadu. Membawa terbang menembus ke awan, berlapis langit berjalinan. Separuh nafas berharakan, siap demi baktiku pertiwi. Untuk masa depan, bahwa kita takkan mengalah meski hidup taruhannya. Cinta negeri mengalahkan segala, tak satu pun jadi kendala. Biar nafas hanya separuh, tak rela ku mengadu. Membawa terbang menembus ke awan, langit berjalinan. Separuh nafas berharakan, siap demi
Thank you for your attention.
Terima kasih atas perhatian.
We are now continuing our meeting to the next session. That is to hear the keynote speaker, which will be delivered by Professor Wanti Wijaya, Mr. Nathanael Karyanto, PhD, Dr. Ismail Raob, Dr. Anwar bin Moh Yusuf, Dr. Delsi Kariman, MSI. The keynote speakers will be moderated by Mr. Ramadhani, MPD, PhD.
Selanjutnya, pemaparan materi yang akan disampaikan oleh narasumber kita, Ibu Profesor Wanti Wijaya, Bapak Nathanael Karyanto, PhD, Bapak Dr. Ismail Raob, Bapak Dr. Anwar bin Moh Yusuf, dan Ibu Dr. Delsi Kariman, MSI, yang akan dimoderatori oleh Bapak Ramadhani, MPD, PhD.
Mr. Ramadhani got his bachelor degree in STKIP PGRI Sumatera Barat and the master degree in Padang State University. Then his PhD degree in National Donghua University. Some of his research are in 2021 is about enhancing flipped classroom with peer teaching to promote students' conceptual understanding and self-efficacy in calculus courses.
Bapak Ramadhani merupakan salah satu dosen di program studi pendidikan matematika STKIP PGRI Sumatera Barat. Beliau menyelesaikan pendidikan sarjana di STKIP PGRI Sumatera Barat. S2 beliau di Universitas Negeri Padang dan beliau juga melangsungkan S3 di Universitas Nasional Donghua, Taiwan.
Ladies and gentlemen, please welcome Mr. Ramadhani, MPD, PhD. Time is yours.
Kepada Bapak, waktu dan tempat disilakan.
Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you MC for the time is given, and good morning everyone. Okay, for this morning, I will take a control of the session. I'm Ramadhani as moderator, and I would like to demonstrate this session part. We will divide into 3 parts. For the first session, it will take over by Professor Nathanael Karyanto, PhD. And then for the second session, it will take by our keynote speaker. Sorry, take out. To make sure the name of keynote speaker. Okay, the second session will take over by Professor Wanti Wijaya and Ismail Raob. And then the third session will take over by Anwar Muhammad Yusuf and Dr. Delsi ICoMMSd. So each keynote speaker has 20 minutes for the lecture and add another 10 minutes for discussion part. Is it clear for all of the keynote speaker? Is there any question? Okay, thank you. I would like to say thanks for all of keynote speaker for your willingness to be a keynote speaker in our conference. And we are pleasure for all of participants to see you here today. So today we will around the world. Are you ready? Please fasten your seatbelt. Okay, to save our time, for the first keynote speaker, Professor Nathanael Karyanto from Sungkyun Kwan University, Republic of Korea. Before the Prof. Nathan gives a lecture, I will read out some of his curriculum vitae. His complete name, Nathanael Karyanto, PhD. His master degree and PhD in Universiteit 20 Netherlands. And his experience 2000 to 2021 maths lecturer at okay. Sorry for the take time. We can read Professor Nathan CV. Okay. Sorry for Professor Nathan, there is a mistake for here because this is my CV. Okay, Professor Nathan, okay, sorry for all of the participants. Please wait for a moment. Hello, Prof. Nathan, do you hear me?
Yes.
Okay, sorry, Professor, for our mistake. I will read your CV later on. Is it okay?
Yeah, no problem.
Okay, now it's your turn, and I will, after your presentation, I will read it. Okay. Now it's your time.
Okay, thank you very much for the introduction, Pak Ramadhani, Dr. Ramadhani. I'm using the classroom here because I plan to write something on the whiteboard, but it turns out I will have only 20 minutes. It's still 10:58, so it's 8:58 there in Padang. Let me share the screen. The presentation slides. Can everyone see the presentation slide right now? So the title is Sturm-Liouville Problem and Planetary Boundary Layers. This is applied problem. Is combination of mathematics and physics, and probably some meteorology, atmospheric science. But the main ingredient is partial differential equation and ordinary differential equation. So these are the outline. But I will discuss a little bit about the classification. Maybe I will use the whiteboard. So after introduction, we will introduce the mathematical modeling based on partial differential equation, and we will approach two different solution, both using asymptotic and numerical, and then we give some conclusion. Okay, what is PBL, planetary boundary layer, or in other terms also atmospheric boundary layers? That is the the lowest part of the atmosphere where we live, because we know that atmosphere has several layers, and its characteristic is influenced by the contact with the Earth's surface, and it can range from few meters to a couple of kilometers, and the temperatures also can vary significantly. It can be very hot during the summertime and can be very cold in the winter time. Well, in Padang is constant between 20 and 30 probably. I came from Bandung, and in the morning it can be very cold. It's below 20 degrees Celsius, and we need jacket. So that's just one example that temperature can drop. And of course, there are some influence from the wind and turbulence as well. The model that I take is from this paper, but I modify a little bit. Is paper published in Boundary Layer Meteorology in 2005 by a group of scientists. If you do not know them, is okay, because it's very specialized field. But people in fluid mechanics know them as a big shot, like Julian Hunt is Sir in the UK, and Frans Nieuwstad in the Netherlands. There's a big shot in fluid mechanics. So they propose a model for atmospheric boundary layers using this convection diffusion equation. Actually, there is 4 common constant, and then the wind speed profile you start over there, and then with some certain boundary conditions. And in fact, this comes from in fluid mechanics. You have a big model called Navier-Stokes equation, the conservation of mass and conservation of momentum, and you have continuity equation, and with some simplifications, you arrive at these equations. Okay, so we already mentioned the name is called convection diffusion model, but that one belongs to the class of partial differential equation. So maybe I can make a large classification here if everybody can see the whiteboard. I guess maybe that's a bit small, but if you cannot see, that's okay. This is a main classification. Everybody who take class in differential equations are aware that the differential equations can be divided into ordinary, which you call it normally with abbreviation PDE, ODE, or in Bahasa is PDB, persamaan differential biasa. And then there is a partial differential equation, and the abbreviation that commonly used is PDE. In Indonesian is PDP, persamaan differential partial differential equation. And then for ODE, you study mostly with linear. The simplest one is of course linear. And if you go further, you can study nonlinear, and the same case also here for PDE. You can study linear case and you can study nonlinear case. For linear, the simplest one is first order ODE, and then you go to second order ODE, and then you can go to higher order, and you can study system of ODE. And for nonlinear ODE, that's in fact is more interesting because a lot of phenomena occur in natures can be modeled with nonlinear ODE, and solving is difficult. So usually people study stability analysis, and then dynamical system. And from there, there is a separate field, chaos and fractal. There's also a separate field by itself. And for linear PDE, the big three that students study in the undergraduate level is hyperbolic type. So what is hyperbolic PDE? An example is wave equation. So U is a wave, and then there is partial derivative with respect to time equals to some constant times, again, the wave equation, partial derivative with respect to x. So there are two partial derivatives on left hand and right hand sides. And then the second one is called parabolic. A well-known example is a heat equation. So this one is just partial derivative with respect to t, and then constant, and then partial derivative with respect to x. And this is describe diffusion phenomena. And the other one is called Laplace equation, or elliptic type. Elliptic type. So Laplace equation, the equation is uxx plus uyy equals to 0. And for nonlinear PDE, this is again interesting phenomena. It's difficult to solve because of nonlinear, but there are some special cases where exact analytic solution is possible. So if you're not familiar, KdV is called Korteweg-de Vries equation, is the name of Dutch mathematicians from Delft in 1895. And then, okay, I can write the equation in case you're interested. So it's ut plus uxx minus ux equals to 0. And then nonlinear Schrödinger equation. If you take a class in quantum mechanics in physics, you have heard Schrödinger equation. That is the linear part. The nonlinear part has nonlinear term, absolute value of u square times u equals to 0. That's the whole equation. And then sine Gordon appears in superconductivity. So it's extension of that, similar like this wave equation, but with some nonlinear term, sine u equals to 0. So there is term sine, and therefore is called sine Gordon equation. So my PhD work is dealing with a freak wave. It's a very large wave using NLS equation. It can be derived from KdV equation. So then what I will talk today is about this heat diffusion equation extension from that one. As you can see here, so if this u equals to constant, then that one reduced to the heat equation. So what that Ovino paper, this u is linear function. So I want to make it general, and that u term there describe the vertical distribution of the horizontal mean of wind speeds within the planetary boundary layer. And of course, PDE doesn't work if you don't have particular conditions. So we have initial conditions here given by psi, and then we have two boundary conditions. Let's say at z equals to 0, let's say at the lowest part of the planetary boundary layer, maybe at the surface of the Earth, and then some portion of at the end of the layer at z equals to z1. So now we have to solve this one, and this is difficult problem. It depends on what kind of wind profile you have, depends on the wind speed you have, and so on. Depends on the initial condition you have, and so on. Now, for the special case, which is I wrote there on the whiteboard, where the wind speed is constant, you reduce to the heat equation. And this is a very well-known topic in any, you can find it in any textbook in PDE. First, for Dirichlet boundary conditions. So Dirichlet conditions is the temperature at one point and the other point fixed to a constant. So here I indicate with the blue color. And if I make initial condition with linear function theta equals to z, and that's what happened. So the temperature goes to 0 as times goes to infinity. And then if I change the boundary conditions to Neumann, where the partial derivative with respect to z of the temperature equals to 0 at both endpoints, then it shows a different quantitative and qualitative behavior. Of course, for the long term, the qualitative behavior remains the same. It eventually goes to 0 for the same initial condition, but initially it shows a different phenomenon. Okay, and then of course you can play with the boundary condition. You can mix. The mixed boundary condition is called Robin boundary conditions. That's what we presented in the previous slides, and you can get a different picture. Okay, so let's solve that one. I separate the situation into steady state and non-steady state. Steady state does not depend on time. So when you take limit for t goes to infinity, the temperature depends only on the position. It does not depend on time anymore. So then the PDE reduces into ODE, which I can solve with these boundary conditions. But the non-steady state part, I denoted here with theta hat. It remains satisfy the PDE with initial conditions modified by subtracting this the steady state function. But the right hand side here, before it was constant 1 and constant 2, and here becomes 0 because the C1, C2 is absorbed to the steady state part. Still complicated, but nevertheless it should be simpler. And then using the method of separation of variables, so we have variable in z, we have variable in t, and then you separate. And then from one PDE, we get two differential equations. We get two ODE, and with initial condition is called initial value problem. I think in Bahasa is called PNA, persoalan nilai awal. So we have initial value problem for this function tau that depends on t, and t denotes time over here. And the other one is we get boundary value problem. So that was, I think, persoalan nilai batas, PNB in Bahasa. So we get initial value problem and boundary value problem for tau and y respectively. Now, lambda is a constant that we need to find. And the same thing, we need also to find y, and we need to find tau. Okay, so we have only two problems, but we need to find three quantities, so that's quite troublesome. For once you get the steady state and non-steady state, then you just add together, and the constant you can use orthogonality, and that's the expression. Maybe I just leave out the detail. So let's now focus to this boundary value problem for the function y. The expression with the boundary condition, the PDE with the boundary condition, is called Sturm-Liouville problem. So it has been investigated a long time ago by Sturm and Liouville, and then with some transformation you can transform into Liouville normal form with certain boundary conditions. And Q is called invariant function, and this is the transformation that I impose. So instead of focusing on the canonical form, I focus on the Liouville normal form, that one. The asymptotic solution is implemented using WKB approximation, Wenzel-Kramers-Brown approximation. This is again, well-known technique in quantum mechanics, but I applied into problem in atmospheric science. So there is assumption that this invariant function should be slowly varying. So it's not rapid moving in terms of vertical position. And if I define capital Q, the invariant function minus the eigenvalue, that also should be varying, slowly varying. To solve this one, I introduce a Riccati variable. And then if I substitute, I will get a Riccati differential equation. So from linear ODE, actually I have linear ODE. By introducing this variable, I get nonlinear ODE. So people are wondering, well, you get linear, and you suppose the linear equation is supposed to be easier, but why you make it nonlinear? Because that makes life complicated. It turns out that the answer is not that complicated, because there is another step that we take is expanding R into asymptotic series. So my Riccati variable I write as R0 plus a small variable epsilon times R1 plus epsilon squared times R2 and so on. So then if I substitute back to the Riccati equation, I get equation of order epsilon to the power 0, order 1, which is just R0 equals to plus minus square root of Q, where of course it depends whether Q is positive and negative. You have to define carefully. Here, if Q is positive, I write square root of Q as K. If Q is negative, I define omega as square root minus Q. And then the next step, once you find R0, you can find R1 by solving this one, the equation of order epsilon, and you can continue. So, but normally for what is the so-called WKB approximation, you just use these both terms R0 and 1 and R1. If you like, you can go to higher order terms. So here are the solution. So again, it depends on whether the value of Q is positive or negative. You can express in terms of exponential or exponential to the power I, which reduced to sine and cosine, which it turns out oscillatory. So we have exponential type and oscillatory type solution, WKB solutions for the solution of our Sturm-Liouville problem. So here are the two expression, the two solution, the same solution expressed differently. One is using exponential, the other one is using hyperbolic cosine and hyperbolic sine, and using the regular trigonometric function sine and cosine. I think I have to hurry because I have 20 minutes. Now the problem is, what happens when Q equals to 0? Because if Q is not 0, whether it's positive or negative, you get the solution. That's fine. But the problem here is what happens when Q equals to 0, or what happens when Q near 0. So the treatment is using Airy function, and that point where the function equals to 0, the point z, where z equals to lambda, zeta c equals to lambda, where q zeta c equals to lambda, that is defined as a turning point. So there is a transition from oscillatory to exponential, or vice versa, from exponential to oscillatory. So the solution is given by this function AI and BI. AI and BI are Airy function of the first and the second kinds respectively, and it's defined by improper Riemann integral. So AI is defined as 1/pi integral of cosine of this expression, and then you integrate from 0 to infinity. So what makes improper is because the boundary goes to plus infinity, so therefore it's improper. And the second one, second type of Airy function is given by the notation BI. So that is just replacing cosine with sine, but there is additional term of exponential over there. And again, is improper because of the upper boundary goes to infinity. So now we have region. If I may allow to write here, so to describe the situation, we have the region where Q is positive or negative, and then over there where Q is positive or negative. So let's say Q is negative over there, Q is positive over there, and here where Q equals to 0, here you have turning point. So here the solution is using Airy function or combinations of Airy functions. And when Q is negative, then you get oscillatory. And when Q is positive, you have exponential type solution. And the solution should match if you require the condition on the coefficients. So here are the coefficients, the conditions for smooth solution, the coefficient conditions for the smooth solution is given by this expression. So it depends on a number of parameters there, as you can see. That's the plot of Airy function. So that's the AI function, the blue one, and then that's the BI function of the red one. And it actually, the problem comes from optics, or it has application in optics and also quantum mechanics. The person itself, George Biddle Airy, who lived in the 19th century, is a British astronomer. So I guess the problem originally come from astronomy. And the convergence can be checked using Dirichlet test. I think I will not go into detail, but it's very easy to remember if you see this type of differential equation, or that's Airy differential equation. Okay, so far so good, except that we do not know what is the eigenvalue. So there is a technique to approximate eigenvalue using landscape function and potential function. Effective potential, sorry. So landscape function is if the right hand side equals to 1 here, and then effective potential is 1 divided by this phi hat. And the lowest eigenvalue is 5/4 times the minimum value of the effective potential. That was proposed by this paper by Filoche and Boroda in 2012, and also Arnold in 2019. I will see, we go to examples and then we should be done. So let's consider this problem. This wind speed is exponential type, like that. And if I transform to a Liouville normal form, I will get 1 over quadratic. That's the invariant function. And then the landscape function is solving that one with the same Dirichlet conditions. And fortunately, this has exact solution given by this expression. And then here you can pay attention to this blue eigenvalue 1.53. That's the estimate from the landscape function, but the numerical result is 1.51. It's not that bad, although it's not completely accurate, but at least you can already have some idea that eigenvalue is around 1.5. So once you get eigenvalue, you can find the eigenfunction accordingly, and then you can find the solution. So the blue one is the landscape function, the red one is the effective potential, 1 over phi, and the green one is the estimate. And here is the invariant function, the right picture on the right, the black one is the invariant function, and the green one is also the value, the lowest eigenvalue lambda 0. And here on the bottom left is the solution from the WKB approximation. So the black one is exponential, the blue one is oscillatory, so it's the opposite case with what I draw over there. And then the middle one, if you notice that the black and the blue is just going to infinity, so with the Airy function, that's helped to bridge between the black and the blue. And here on the bottom right is the result from the numerical simulation. It's quite nice and smooth. And here is the solution in three-dimensional case. So now I combine with the t without steady state. It's just non-steady state. So as t goes to infinity, then the profile will eventually goes to 0. And on the right is I scale back into the original variable z. This is the scale variable z hat from 0 until pi. This is from 0 until around 36, something like that. Okay, so let's conclude this presentation. So what we have seen, we try to consider the model for potential temperature distribution using convection diffusion model by modifying the model that was proposed by Owino et al. In 2005, and we end up solving a Sturm-Liouville boundary value problem using asymptotic solution by means of WKB approximation, but also to solve numerically. I use MATLAB actually, and then we can estimate the eigenvalue using the landscape function and effective potential, and by comparison is not that bad result. And then the qualitative comparison also is quite good. So I think I stop here, and thank you very much for your attention. It's 9:25 there in Padang. If you have any questions, I guess I should start. I should stop at 9:20. I take 5 minutes. It seems Mr. Abadi raised hand. Is there a question? Okay.
Okay, thank you, Professor, for this trouble. Okay, this session will be the next session. Before we continue to the discussion part, as I promised. Please. Okay, Prof. Nathan, he is working in Sungkungkyeon University in the Republic of Korea from in 2007 to 2010. And then his education study Bandung Institute of Technology. And then he had a lot of we can see a lot of his publication, such as physics of fluid, mathematics, nonlinear dynamics, and then next. Next. Okay, this is some of the Professor Nathan CV, and he also supervision in University of Nottingham, Malaysia, in previous university. And this is some of the funded research. We can see he got funding from National Research Foundation around $80,000. It's a lot. I think it's around 1.2 billion rupiah. And then another for the teaching, he is teaching foundation algebra, foundation mathematics, pre-calculus, mostly on calculus, discrete mathematics, and applied statistic method. This is only a little bit. And then the last one, I think he also editorial reviewer in some article, symmetry, mathematics, enthusiast, person differential, Springer. So this is like our relation. Maybe when we would like to submit article, maybe we can contact Prof. Nathan. Okay. Okay. Now times to discussion part. I saw this is Mr. Abadi. Raise hand, please, for the Mr. Abadi.
Hey, thank you. Thank you, Professor Nathan. This was great talk from you. Yeah, I just need some clarification about. Maybe I missed your explanation about. You start with the convection and diffusion model, right? And then maybe I missed your explanation about how it just change into Sturm Liouville problem into ODE, right? Please explain again. And then is it boundary layer problem? Boundary layer is equal to Robin boundary condition.
Okay, thank you, Mr. Abadi, for the question. So the first question is how to change from convection diffusion, that was PDE, into Sturm Liouville problem, which is ODE. So the technique is using the method of separation of variables. So the theta, which is a function of z and t, you write as a y, that function of z only, and then tau as a function of tau function of t only. So by writing as this separation product of two functions that different variables, then you substitute back, and then you will get initial value problem for t and then boundary value problem for y. That's how you get it. I guess. I hope that's clear. And the second,
yeah.
Sorry.
Yes, about the boundary layer and.
Yes, the second question is the boundary layer is the same with the boundary conditions? The answer is no. So boundary layer is the layer. So in this context, in this application problem, we are talking about boundary layers in the atmosphere, in the planet. So that's between the surface of the Earth and then the certain part of the atmosphere. When you change from the lowest part, I cannot recall the name, like there is troposphere, there's stratosphere, and this kind of names that we learn in high school. So that's the lowest part, and that's the boundary layer. But the boundary conditions is the condition at the end of these boundaries. That's what I meant. So it's not the same, but it's related.
No, I mean the Robin boundary condition. Is it the boundary layer itself?
The Robin, you mean?
Yes.
The Robin means mix. Mix between the Robin boundary condition is a mixture between theta at 0. So maybe there's some constant here, plus alpha 1, the derivative of theta with respect to z at 0 equals some constant. So this is called Robin boundary condition. Robin boundary condition is a mixture between Dirichlet and Neumann.
Yeah.
Okay.
So it represent the boundary layer condition, is it?
Yes.
Okay.
Yes. Okay, thank you very much.
Yes, thank you.
Thank you.
Okay, I think it can be answered the question from Mr. Abadi. Now is there any question from other participants? If you have a question, you can raise your hand or type a message in comment. Okay, because there is no question, so now the time is up for 30 seconds. First, I would like to say sorry for everyone because of our connection problem. And for this time, we would like to ask Professor Nathan to receive the certificate as symbolic from our college.
Thank you very much.
Yeah, this is the certificate.
Okay, I accept it. Thank you.
Okay. Give applause for the Prof. Nathan. Thank you. Okay, next, Prof. Nathan, I know you have another activity after 10, but if you would like to join us until the end of this session, we are so pleasure, and then we also hope you join with our parallel session later on after 1 p.m. in Indonesian time to give some suggestion for our research to develop. Okay, thank you, Prof. Nathan.
Thank you. My pleasure.
For the second keynote speaker and the third keynote speaker for the second session. So the second keynote speaker, Professor Wanti Wijaya. I will read her curriculum vitae first, and then her education background in graduate certificate of higher education, Deakin University on 2013, and then Doctor of Philosophy Education, University of Melbourne, 2008, and then Master of Education in Boston University, 2002. Her experience, 2007 to 2010, as assistant professor in the University of Nottingham, Malaysia, and then 2010 to present as assistant professor in Sungkyun Kwan University, Republic of Korea. I think
that's a wrong CV.
Yeah, sorry, Professor. Again, I will read out later on your CV.
You don't have to read my CV. That's okay.
Okay, for the other participant, if you would like to look at the Prof. Wanti and Prof. Nathan and another keynote speaker CV, you can Googling in Google Scholar. You can see a lot of their research. They are so amazing for the research. Okay, that's all the introduction from me about the Prof. Wanti Wijaya, and now it's time for you.
Thank you. Thank you, the moderator. So may I share my screen? Is that all right? I'll try to share my screen, and hopefully if you can let me know if you can see that. Can you all see it? Yeah, all good. And can you hear me okay? All good. Okay. So I'm Wanti Wijaya. So I'm currently working at Deakin University in Melbourne, Australia. But I'm originally from Indonesia. So later on, if you have any questions and you would prefer to speak in Bahasa, please let me know. I'm happy to answer just a little bit of background or about Deakin. If you haven't visited Melbourne or Victoria, so Deakin actually have 5 campuses. So I'm based at Melbourne campus at Burwood, But we also have 2 campuses in Geelong and 1 campus in Warrnambool, but also we have what we call the cloud campus, which means that the students can actually study anywhere in the world. They're studying online. So today what I'm going to share is very different than what Nathan just shared. So I'm focusing more on the mathematics education. That's my field of research. And also particularly I will be sharing experience in teaching maths education during the pandemic. We all have to move to online and teach online. So I'll be sharing and focusing my presentation on that. I'd like to begin by just highlighting, even though we are teaching maths education online, I think we still need to align with the principles in teaching mathematics, being it online delivery or face-to-face delivery. So these are some of the principles that we would like everyone, maths educator, to promote, so students can learn and have that experience of positive learning of mathematics, so they develop positive attitudes and enjoy learning mathematics. The importance of holding high expectations of our students, so we want our students to succeed, but also we want to make sure that we set high expectations. But we also need to be mindful that in setting high expectation, we need to also cater or accommodate students with different abilities and capabilities as well. So that relates to this, for example, choosing or selecting activities and tasks and problems that will allow students to build their understanding from within, so they can actually, even if you're selecting rich and challenging problems, all students in your classroom can actually approach the problem in different levels. So that relates to the next point on personalizing learning, and also the importance of inquiry and planning for questions that will allow teachers to elicit students' reasoning, student understanding, focusing on building their communication skills, getting students to explain their thinking, justify their solutions and their process of solving the problem. And also we want students to be able to see connections between ideas in mathematics. So they don't see, learn geometry as sort of like isolated from learning algebra, for example. We want students to be able to see the connections between different areas in mathematics. So there has been a growing interest in blended and online learning. So even before pandemic, we know that there is a online delivery and blended delivery in teacher education as well, maybe more in teacher education, whereas in schools, I think mainly face-to-face, but due to the pandemic, even schools teaching mathematics in school have to be delivered remotely through online learning. And it can be very challenging, especially if schools or teachers are not used to that mode of teaching. At Deakin, we're quite lucky because Deakin is considered as sort of like a leading university in remote distance education. So we actually have a lot of experience and expertise in delivering online and distance education. So when we had to move to online teaching and learning, there is already sort of like a culture of, in our teaching of the unit, for example, we have the learning management system where usually we have to allow for a hybrid mode of teaching. The issue, I think, with online teaching and learning is always, it can be quite challenging to maintain and sustain the high level of engagement because, I think with face-to-face, you can actually read the gesture and, student engagement. If students are bored, you can do something to address that. But sometimes with online teaching, because sometimes when the students don't have the video on, like now some of you probably don't have their video on, it's very hard to read, like, whether or not you're actually following, or, you're not following the discussion and the learning activities. So that is the challenging part, I think, especially for us as teachers or as the lecturer. We do still see the benefit of having the online teaching, especially during this pandemic era where we cannot actually be in the same room in big numbers. But in general, I think with the online teaching and learning, that allows students and teachers to collaborate, even though they are separated by large geographical distances. In our case, for instance, between Melbourne and Warrnambool, we are separated by about approximately 300 kilometers. So when it comes to online teaching, we can actually bring the students together. Sorry, is there a problem?
Can you share slide? Because this is still the first slide.
Is it not sharing?
No, this is our first slide, Professor.
It's not moving. Okay, that's interesting.
Sorry for disturbing you.
No, it's okay. Is it coming up?
Yeah, it's working.
It's working now? Okay, sorry about that. I didn't realize. Okay.
That's okay.
Okay, so I just give some examples of the, for example, virtual manipulatives and resources that we can draw on when we are teaching online. So this is just one example that you can visit the link. And this year we published this paper that is focusing on our reflection on designing and delivering an online lesson study unit in mathematics with our pre-service teachers. And we talk about opportunities and challenges in this paper. So if you're interested, you can actually go and read this article. I will talk a little bit about that experience that we describe or we reported in the paper. So in that paper, I reflected or we drew on the experience of designing a particular unit in our university for third-year Bachelor of Education primary students who are specializing in mathematics education. And that unit focuses on the use of lesson study. So in teaching that unit, we follow or we give them experience of structured problem-solving approach. And that these slides describes the focus of structured problem-solving approach according to Takahashi model. Can you see the slides moving? Yeah. Okay. Yeah. Cool. Okay. So this slide gives you an idea of how we carried out the teaching. So as you can see in the picture, the slides on the left-hand side. This was from this year, actually. So in the first week, I talk about the students in Warrnambool and students at Burwood campus. So I'm teaching those students from those two campuses who are separated by large geographical distance. So in our teaching, we had to set up like a virtual meeting point or meeting conferences. So the students at Burwood campus, they can actually interact or see their peers in another campus. So that is the view on the left-hand side, and they're all doing the same task. So for example, they're solving that super snooker problem, and then as a lecturer, I need to moderate that discussion. So we will invite students from different campuses to share their solutions and discuss their ideas as well. So for that particular problem, we encourage our pre-service teachers to really use a diagram to think about the different methods of solutions or strategies to solve the problem. And this way, I think we would like to give them the experience of really solving the mathematics, engaging with the mathematical problems, but also anticipating what students will come up with, like the different type of solution. And sometimes this is quite different than their own experience, because sometimes they can come up with like solution 1 and 2, but maybe that's it, like, you know, and then you have to push them to think about other solutions and be more creative and thinking about, if you're giving this problem to students, what would the students be able to come up with? But also, I think pushing the thinking towards generalization as well. So what happened if, for example, instead of having just that three diagrams, if you extend the problem into finding the general solutions, then they can think about the algebraic thinking and, you know, the generalization basically. So in the next part, I would like to share some of the resources that we developed for our teaching at Deakin. So these are, for instance, the approaches that we did for different units. Sometimes it varied. We varied the approaches. So in this particular unit for the third year students, third year pre-service teachers, we actually prepared have the synchronous and asynchronous experience. So the lecture for this particular unit was video recorded. So for instance, I did the lecture for week 2, and we know that the engagement with video recording, we cannot prepare, like, for example, an hour lecture. They want, people don't sustain that length of watching the recording. So we had to create something that is quite short and snappy. So this year, for instance, for the fraction lecture, I split it into two parts. So you can see the 2 short lectures. But we also have the seminar where we interacted with the pre-service teacher. So we interact with them synchronously, like, you know, so they attended Zoom meeting and we had the activities prepared, and, you know, we asked them questions and they contribute their ideas during that session. So that's more interactive, whereas the lecture, they have to watch it before the seminar. So these are another unit for the 4th year's pre-service teachers. As you can see, there are also resources embedded in each of the LMS or the unit side, where we expected pre-service teachers to actually access those videos, and they were expected to do the readings before the interactive seminar with their peers. So as probably everyone experienced this time during the pandemic and last year as well, everything was delivered through, like, this year we focus on delivering teaching through Zoom. So I had to black out the students because that's not allowed. So basically, this is the example of the Zoom interactive seminar where we get to see the pre-service teachers. If they turn on their video, you can see their faces. In order to make sure that our pre-service teachers had the experience also of thinking and planning and their lessons or the selections of the problems, the mathematical tasks based on students' thinking, we incorporated the use of artifacts from classrooms. So for example, in this case, pre-service teachers had to analyze the student responses and discuss that in their during their seminar. In the lesson study unit, we also used the research lesson video from the school, the local primary school, and we had also sorry, I think there is someone who's unmuted. So we also had a guest lecture. So we had the teacher from the primary school who came and then share her experience with our pre-service teachers. And that is a very valuable experience for our pre-service teachers, because although they had placement, but many of our pre-service teachers couldn't go to school during the pandemic. So they either had the remote placement if the school allows for that, or they had like very limited, like their placement had to be postponed until the school allow our pre-service teachers to come back and do their placement. So These slides talk about the opportunities arising for that particular unit on the online lesson study. So in order to facilitate the engagement and the interaction, we use the chat function, so like what we did today. And also I encourage my students to actually annotate. So at the beginning, usually we had a brainstorm of the readings and the lecture. So we asked the pre-service teachers to share their reflections on the readings and the lectures and annotate on the blank slide. But also when we had them to engage with the problems and solve the mathematical problem, they had to report back, and that's part of the accountability, where they also had to share their solutions and then discuss that. I talk about the engagement with the video recorded research lesson from a local primary school. That was very good. And also we structured the observation of that research lesson by getting them to really read the lesson plan beforehand, discuss the lesson plan beforehand, but also look at the students' solutions. So we hope that all those experiences help our pre-service teachers to prepare themselves when they are facilitating the online teaching and learning with their students. Some of the challenges for the lesson study unit, I think it's quite challenging to simulate the Blackboard arrangement when you want to actually show multiple solutions, whereas I think like the Blackboard arrangement sometimes only allow one group to share their screens at the time. And we try to address that by splitting the screen into 4 and then get them to annotate. But it's still a little bit challenging. Also the limitations of for our pre-service teachers, because they couldn't actually implement their lesson plans in schools, the novelty of online lesson study, but also I think that the other challenges is to actually how to establish the social norms for our students who haven't seen each other for a long time. And if they actually started uni last year, for instance, when the pandemic already hit in March, so basically they started their study online throughout, in the first 2 years. And because they haven't met their peers face-to-face, it's actually quite challenging to establish that social interactions and engagement for them. I don't know whether I still have time, but if I still have time, I would like to showcase this new learning precinct that we have at Deakin. Do we still have time?
Okay, Professor, I will give you 3 minutes.
Let me see if I can share, if you can see actually that video or not. Is it coming up or not really?
Not really.
Okay, so I think I have to stop sharing this one first.
Okay.
Wow, this, and then share sound, I think. Can you see the Facebook page now?
Yeah.
Okay.
From the moment they step in the door, you can see their eyes light up, and it's a wow factor. And so we've got their attention. When students and participants come inside to this environment, they are captured for the entirety of what we're delivering, and that's amazing. That's something that we've never been able to do in the past.
We can actually put our students in the same room and they can look around the room, they can freeze the frame, they can see things that they didn't see before, they can see things that are often hidden in plain sight. And that's when they start to learn. So it helps us provide that really rich, immersive experience in a social context.
You might come inside here and get a shared virtual experience to see what's happening. You might go outside into the round think tank to discuss that, critically analyse what you saw, then maybe come back in and look at a different picture and immerse yourself into that. So the two rooms will be used in sync together for our student learnings. our academic staff who maybe are not used to teaching in such format. This is different, and so anytime there is a different space with different technology, it requires a whole new learning set. So that was soon alleviated when it was built and they came in the first time. And then I think from that moment on, the spark has been lit in their mind about how they can use this great facility to enhance the delivery of their teaching.
We had it recently and we all went to Bondi Beach. Then we went to the Coliseum, all in a matter of 5 seconds. And that's pretty powerful when people have an idea and they just go there. So it is, they're really quite stunned with the technology, and then they start to see what they could do with it in their own teaching.
So we've done some content around teaching in schools. We have a number of teaching students and who have to go out and do some placements. So being able to bring them into a shared environment like this, a 360 environment, we can talk about some of the concepts that they're learning in the classrooms, and they can actually experience that through some of the footage that we've been able to capture already.
I mean, it helps our pre-service teachers in particular see the sort of dynamics that are happening in a classroom. We can take them into a classroom, they can see the group learning dynamics that are happening. They can see the sorts of things that you would otherwise miss often when you're in the busyness of the moment. So, I mean, it's a very powerful tool for looking at an experience and then re-looking at an experience once you've learnt something.
The possibilities of this space is endless. The usage will continue to grow as we get more people through.
Yeah, I think that's it from me today. So thank you for your attention, and I would love to hear your questions or your feedback. So terima kasih, and saya tunggu pertanyaannya.
Okay, Professor. We are so amazing with your research and interest, especially for me. I'm doing online learning for the 4 years in Open University, and I have a lot of question about you, but we need to hold on for we will give time for the third keynote speaker for 20 minutes, and we will have 20 minutes for discussion together, both of you. Okay, Professor. Okay, now our third keynote speaker turn. The name is Dr. Ismail Raub. He is from Fatoni University, Thailand. So we also have the network with Fatoni University for the several years. So Professor Ismail Raub, history background for study in major statistics and research methodology, Faculty Educational Studies, University of Science, Malaysia. And then major education measurement and research faculty education, Prize of Songkhla University, Thailand. And his experience become director of research and development, Fatoni University. Some of his research about community action plan linked to province strategic toward driving a learning platform using masjid-based multicultural society of Patani province, Thailand, and the development economic absorbing platform on Halalan Toiban, Kari of Batani community enterprise in Fatoni University network market, and then the development of economic absorbing platform on organic vegetable farming and Halalan Toiban to Patani ASEAN Mall. So we can see from his background, he like to do research about the something and relate to religion, I think. Okay, now I will give time for Professor Ismail Raub for 20 minutes for the lecture. Now it's your turn.
Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrofil mursalin wa ala alihi washabihi ajmain amma ba'd. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to say thanks Allah Subhanahu wa Ta'ala that He gave the opportunity to come here today. I'm Ismail Raoub. I come from Fatani University, the southernmost Thailand. Okay, I would like to present my paper about firearms educational assessment strategy of the COVID-19 in Thailand. I will begin by present my area-based research in my university. Now we are conduct some of research about economic, local enterprise, innovation, community, education sandbox, and the challenging in the world. Now and also we do everything about of education and the positioning of Fatani University. Now we strategic profile to local products. And also we integrating Islamization for peace that we are the Fatani University. Let's start with the Thailand weekly situation about of the coronavirus. That time now, you know, the case, the count remain high, more than 9,000 in Thailand per day. And also the number of deaths continue to decrease with the average of the 76 days per day. And now also we have so many people died about the coronavirus. And also now we observe case the decreased by the 6 and 3 the last week. And you know the situation in the southernmost Thailand, you know the southernmost the majority of the Muslim. And now we challenge the big problem about the coronavirus. In Jala, you know, we have more than 600 to got the virus, and also Nakhon Si Thammarat more than 60. Patani and Narathiwat also. Those 5 people account for 29 of the confirmed the coronavirus in the southern Thailand. Education in Thailand, you know, now the school must be closed because the effect from the coronavirus, and also that effect linking to the learning losses. And how we can design our study in school in Thailand. We have focused on for learning management system on site, on demand, online, on hand, and on air. Let's start from the designing and organizing experience for Thai kindergarten students. We have just only 3 ons and brain and author on hand, online, and on air. The first one on hand, how we can do for the student. The first one we just only students submit a worksheet and activity, no need to study by on site because we cross school every school in the Thailand. And then the teacher must be provide the school children to the parents. Now you know the parents must be to the teacher now. We cannot teach in school. And also when we count the number of hours according to the activity, we can account the worksheet and activity only, no need to study on site. And the second one, online. Now we have so many various online channels, such as the Line group or the Facebook group. Like that, we have so many online. We can communication together between teacher, parents, and the children. And also we count the number of hours according to activity. Just only activity, no need to come to on site. And also the children should not be in front of the screen more than 1 hour because the eye must be relaxed and take the rest. And also must be under the supervision by their parents, no need to online every day because that sometimes the student like to play game and we have to separate only 1 hour to in the screen job. The next, the on air. What is the on air? The Thailand prepare about the DLTV online learning. We have so many channels. And also we have the digital TV for the student. The student can download the document, the worksheet from the website, and then we can learn by themselves or learning by the parents, father and mother. And also we count the number of study by DLTCV teaching and in the schedule. And also sometimes we blend between online and on hand. And also the teacher must be organized activity using the various learning style. Under the teacher she or he can design everything. And also we have the the student must learn about the most explore, observe, or any activity. Then we can learn by experience by themselves in that home. And the next slide, my next slide, the point is the guideline for the teaching and learning to be flexible during the epidemic situation of the coronavirus in the Thailand. Now, the previous time we have the normal teaching, and now how can we do and how can we teaching in the COVID-19? Now we change everything. We have also nine items. The first one, we have the course, right? The previous time we study course arrangement every subject. Student in Thailand must be study 8 subjects. And then when the teaching in the course Vina, we can organize by specific subjects, such as we study only mathematics, science, Thai language, and English. And the other subject we no need to study because there's not enough time to study and to evaluation. The next, the curriculum KPIs. The previous time we teach on in the indicator on the KPI, and now we can emphasize the indicator that must be known and they integrate with the way of life. We cannot teach every indicator and KPIs. And the teaching style, the teacher can mix study depend on of the teacher. We can arrange the class and according to style. And the previous time we just only on-site study by school, and now the teacher can choose the online or on demand or on hand. Next, the role of the teacher and parents. Now the teacher and parents work together to promote and develop learning because the student cannot go to school. The teacher and the parent help together to develop the learning of students. And what is the assignments? Now assignments ministry as a teacher integration together, and also sometimes the parents done the assignment for student because the student not enough time to do like this. And what the time, the timer. The previous time we start the class from the 8 o'clock until 4 o'clock. Now we cannot do like this. We can just learn by the online, and we not completed 80% for the study time. Depend by school and by the teacher. And what about the assessment? The previous time we assess by the formative and summative assessment. And now we move everything. We just see only the workload, the homework, or behavioral, or and some assignment activity. And the evaluation for the national test. The previous we have the ONET RTNT test. And now we discontinue ONET, no need to test. And also RTNT test, we volunteer some of school. If school need to test, we also prepare from the student. How we can do when we got the problem coronavirus, the educational assessment strategy of the COVID-19. We analyze from the SOAR analysis, SOAR analysis, and what is the strength of the student in Thailand. We have the competency-based assessment Also integrating knowledge and skill. And what is the opportunity to teach and to evaluation in the Thailand? We have authentic assessment, and also we have the ICC online testing. And what is the aspiration for students to learn and to study in the COVID-19? Also the Thailand got the resilience and also learning loss. That true, that inspiration, how students can prove when we not the learning, and also the goal, the result for the SWOT analysis. We have to go to assessment for learning, assessment as a learning, and assessment of the learning. Coming on to the SWOT analysis, when the first one, competency-based assessment. Now in Thailand, we move to competency-based assessment because the learner must demonstrate an ability. We need focus on the ability or skill student. And the previous time we focus on the knowledge, but now we cannot design study to on site. We study by on hand or online, and then we move change to the ability and the skills of the student. And also the next integration, knowledge and skill. Student must be college by the extract knowledge and skill from the various. Also now student can learn skill and ability at home, and the knowledge sometimes student cannot get the idea from the study. And how can get from the opportunity? The first one, authentic assessment. Now we cannot decide to the evaluation form to get the test, and now we can authentic assessment by school. And also the ICT online testing in Thailand, when we need to the test, we use the Google form to test. And also sometimes we play game like the Kahoot game. And also we have the live worksheet. Live worksheet, that's the drag and drop games for students to learn and for the assessing. And sometimes we use the wizard game also, and what raw also the game. Student play game and student can learn by game. And we have the quizzes also is the game on of the ICT online testing, because the Thailand position to online teaching and evaluation, that we are so many online. And how can do the inspire? The first one, the resilience. The Thailand, we do the resilience because the student got the corona. And then the parent also, how can we design? The first one, the room for the social development. And we decide their emotional well-being because they got so many things. And also the positive. How students think about the positive? And what about the learning losses? Now the student cannot go to school, and student cannot learn a lot of knowledge. And where is the knowledge and where is the skill or ability of student? We cannot learn, we cannot study. That's the learning loss in the Thailand. And how can we do the assessment for learning, assessing as a learning, and assessing of learning? We can change the goal. To go in Thailand, we have two reflection between teachers, student, and parents. The first one, assessment of the learning. The previous time we serious about the summative evaluation, like that's the product evaluation and achievement test. That's time the evaluated by the teacher. And the second one, assessment for the learning. We focus on formative evaluation. We do the process evaluation of student and progress evaluation. And also who is the evaluator? That's the teacher. And now we move forward to the assessment as a learning. And now evaluated by student, because of we cannot decide to do the summative and formative. And we just only assessment as learning, how the teacher do and how we should the student, and then we can evaluate like this. Okay, the last slide. Imam Umar bin Al-Khattab, he said that hasibu anfusakum qabla an tuhasabu. That's meaning just yourself before you are judged. What is the meaning? the Islam, we have the malaikat to evaluate, to assist all of the human every day, every time. But just only teacher or student, we can evaluate it by term or by semester or by year. And then we can show the answer the question, what's the true and what's wrong. But in Islam, we cannot show what do you do, and then we can show you in only the akhirah, the Jamun akhirah. That is the big problem, and we can do, and we can be careful when you stay live in everything. Okay, terima kasih. Any question?
Okay, thank you, Professor Dr. Ismail Rauf. So I'm so interested in how do you direct self-reflection to Islam ayah. It's so interesting. Okay, now time for discussion for both of the keynote speaker, for the Professor Wanti Wijaya and Dr. Ismail Rauf. For all of participants, if you have question, please raise your hand. Is there any question, please? Okay, for the Mr. Abadi, please.
Thank you, Mr. Chairman. I'd like to ask to Wanti. It was interesting topic that you presented here. Sorry. Oops.
Yes.
Sorry. Okay. But you present about the lesson plan in online learning, right? But my question is about, is it still problem for teachers, yeah, to plan this kind of learning for students? Because in Indonesia, that many teachers has problem with that because in online, because they complain about that. Not so easy to interact with their teacher, their students. Yeah, that's a problem for them, because actually, especially when teaching mathematics, that everything is abstract, but they try to realize to their student, but there's no interaction. So I think, what do you think about it? Because what you present in your presentation is everything is set up there, because the infrastructure is there and so on. But what should we do in Indonesia in this our situation like now? Thank you.
So I guess it comes back, and it's challenging here as well, like, you know, because it really depends on, I talk about the norms that you have to set up with your pre-service teachers in our context at the university level. But as teachers, I think you have to establish that social mathematical norms with the students, that they have expectations to contribute and engage in the activities. It's harder online because, like if everyone is not, if you cannot see the students, it's very hard. But I think in terms of our role, when we plan the activities, I think I'm currently using Zoom for teaching. So with Zoom, I think it's possible because you get, if you can prepare activities and problems, but also engage students by getting them to solve the problem and share screen, that makes it interactive rather than, you know, just sending the worksheets and then getting them to solve the problem. There is no interaction. So with our seminar, we make it interactive because we had that conversation with students and with our principal teachers, and then really prepare the problems and then get them to solve the problems. And we use the breakout groups a lot. I think they feel it seems to be working better. Like if they are in a smaller group, I noticed that when we put them in the breakout groups, they tend to be more willing to turn on their videos with their peers, like in a group of 4 or 5, and they can interact more freely. And then so we allocated some time for them to discuss in their breakout group, and then make sure that they take a screenshot of their solutions. And when they come back to main room, then we invite them to share their strategies and the solutions using share screen functionality. So that makes it more interactive in that way. But again, I think you have to keep encouraging our students to. It takes time, I think, probably to set up that sort of like norms. But once they are used to it, I think they're getting more engagement you get more engagement from students. But I think choosing the tasks that are really interesting and also excites them. Avoid giving them just worksheet to solve. I think that is very passive if you want the interaction, I think. I don't know, in terms of the platform in Indonesia, do you use Zoom in teaching in schools, or do you use Google Meet or Google Classrooms, that sort of thing?
Yeah, that's kind of problem, because in the Ministry of Education in Indonesia already provides to teachers for that kind of software. Like they provide kind of Google Suite, yeah, for students and for teachers, yeah.
Yeah.
In the certain websites, and then, but the problem is still teachers lack of using pedagogy online pedagogy.
Yeah,
That's a problem still.
Yeah, it has to be supported, I suppose. Like, teachers themselves have to experience that online learning.
Yeah.
And then, when they experience that, and then they can then translate that experience to support their students' learning. It's very challenging. I wouldn't say it's easy.
The last thing, the Chairman, but what do you think about the plan the learning for this? Because we are going to post-pandemic, so.
Yeah. So in our case, it's the university actually encourage a hybrid, so a mode of delivery. So it's a blended version of face-to-face and online as we transition. Especially, I think the hybrid mode is useful because often we don't have staff in Wonderful, for instance, to teach our unit. So having that blended mode of delivery, it's helpful when you don't have any staff to teach students. But I suppose in terms of the teaching, the lecturer's role, it's more challenging because you have to sort of like prepare the 2 different platforms, to facilitate the learning. Yeah.
Thank you.
Thank you.
Okay. Is there any question? Before this one, I would like to say for all of participants, because I got a text from the participant, could they ask in Bahasa? That's okay, you can ask in Bahasa and I will translate for them. Jadi untuk semua partisipan boleh bertanya dengan bahasa Indonesia, nanti saya bantu untuk mentranslate-nya. Oke, selanjutnya silahkan yang ingin bertanya, silahkan angkat tangannya. Okay, for all of you, if you have question, please raise your hand. Okay, okay. There is question from the Hafiza. Okay.
Hafiza dulu.
This is raise hand from the Miss Self Nourishment, please.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang semuanya. Baik, di sini mungkin saya akan bertanya kepada Mr. Ismail Rob, ya, karena saya tertarik dengan penelitian beliau ya dengan tadi. Yang saya tanyakan di sini adalah di saat pandemi sekarang atau di era corona itu kebosanan siswa dalam belajar itu sangat tinggi. Nah, kira-kira strategi apa yang bisa kita gunakan untuk mengatasi kebosanan siswa dalam pembelajaran daring ini? Ya, dan juga bagaimana cara menumbuhkannya semangatnya kembali, karena di awal dulu mereka belum terbiasa untuk pembelajaran daring gitu. Sekarang mereka diharuskan untuk pembelajaran daring. Nah, itu saya melihat sendiri bagaimana siswa-siswa itu belajar tidak sepenuh hati. Jadi kira-kira kiat-kiat atau strategi apa yang mungkin bisa kita terapkan. Mungkin itu saja. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Ms. Sefna. I will this question for the Dr. Ismail Raoub. This is related with the condition of this pandemic era. So students feeling bored in study because they have the new one. Because they usually study in classroom and face-to-face. Now they face the another things. So the question is how to solve this problem, how to improve their motivation, and how to develop their skill in other ways. Thank you.
Okay, now we have to accept the coronavirus, and then we can change the pedagogy for the teaching, and the facing the student have to borrow and no reflecting to the teacher. And in Thailand, we normally the student need to learn game. Every student, I am sure every parent have the smartphone, and also students have to play game. And then how we can change game, the other game, and including the content knowledge of game. And then the Thailand, we prepare the game for the knowledge, and then students can learn by game. And then we not borrow because we prepare every day. But sometimes we learning lots about the social skill because they cannot go the other way. We just stay in the home at home with the parent. The key man, I think the parent, we need to design the learning by home, like school home. The parent is the important things to design and to decide how students can learn together by parents. I think the parent is the important to learn in the situation coronavirus. Thank you so much.
Okay, so the point, okay, I will translate in bahasa. Jadi cara yang bisa dilakukan di Thailand itu ada namanya sekolah di rumah. Nah nanti itu orang tua yang membantu berkolaborasi dengan sekolah untuk meningkatkan kemampuan siswa begitu. Berbeda dengan kita, mungkin kalau kita orang tua ada yang membantu atau tidak. Kalau ini emang ada tugas orang tua gitu, ada tugasnya yang harus dilakukan. Oke, mungkin itu saja. Oke, is there any other question? Please raise your hand. Okay, now for the Miss Hafizah. Yeah. Please unmute. Please unmute for. Okay, you can speak now, Miss Hafizah. We cannot hear your voice. Sorry, operator, can you
Okay, thanks for the opportunity from moderator. I want to ask Mr. Ismail.
Sorry, we cannot hear you. Because the Miss Hafiza here, we can invite him to come here to give a question. Please come here. Bu Hafizah, boleh datang ke sini?
Okay. Assalamualaikum warahmatullahi wabarakatuh. The first time, thanks for the opportunity from moderator. I want to ask for Mr. Ismail. Now, I want to ask about based on what you have said in the presentation earlier. I want to ask about the first about in online learning. I hear you said about communication channel between teachers and parents and children. So you have said about manage communication between parents and students. Now, how to strategize teachers to do it? And then I want to ask about blended learning. In blended, you say about we must emphasis on children to learn through the senses. And now, what is the teacher strategy emphasis on children to learn through the sense and have positive interaction for children to learn happily? So to manage all about this. Okay, thanks for opportunity. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Please for Mr. Ismail Rauf.
Thank you so much. Okay, I will reply your question. First of all, in Thailand, before decide to online learning, the first one, the Ministry of the Thailand Ministry of Education, we train a lot of the teachers. How the teacher can teach students by online, and then we have the training for the parents. On of the school, we train parents how we can use the Google Meet, Zoom, or Google Form like this, or the on-off worksheet. We train a lot of the parents, and then the parent know how can do, because some students cannot do like this, and the parent know everything because we have trained by teachers and by Ministry of Education. And also I know that the student got the problem to the learner skill. We cannot go outside, and we have to do the resilience skill. Resilience skill. We not flexible. We in Thailand we have no the flexible. We can do the resilience skill about the mind student, the positive thinking, and also the well-being of the student. We have the strategy to do like this, and we have the program. This program we train parents also when the student upset, when the student bored, and how the parent can do that like this. We have the program to do, and we have around 20 hours for the program, resilience program. How can the parent do for the student in the correct way now? Thank you.
Okay, thank you. I think it can be answered question from Miss Hafiza. Okay, maybe one more question before this session will be end. Satu pertanyaan lagi untuk keynote speaker yang kedua. Disilahkan bagi yang bertanya dengan bahasa Indonesia boleh. Untuk membuat sama gitu dua-dua. Please raise your hand. Khususnya untuk mahasiswa yang mengikuti ya, belum ada yang bertanya dari tadi, silahkan bertanya. Okay, I think everyone will feel good with this session. I think enough because time is also limited. And now times for keynote speaker to receive the certificate from committee. This is the certificate for Professor Associate Professor Wanti Wijaya.
Makasih. Thank you.
Sama-sama. Give applause for the Prof. Wanti. And then next slide, this is the certificate for Dr. Ismail Rauf.
Terima kasih.
Give applause. Sama-sama. I hope you feel good after this conference and we get a lot of knowledge from you. Thank you for your willingness to be a keynote speaker. And then we also hope you will join with us until the end and also for the parallel session later. Okay, thank you, Professor. Now times to the third session for the fourth and fifth keynote speaker. The fourth keynote speaker, Dr. Anwar Moh Yusof. He is from University Kelantan, Malaysia. And his background studies 2017 PhD in education from Edutainment Technology University of Malaysia, and then Master of Multimedia Learning Technologies Multimedia University Malaysia, and his experience tutor, lecturer, senior lecturer, University Malaysia Kelantan, multimedia designer, animation instructor, and multimedia designer. So he also active to make multimedia design. Okay, now times for you, Professor Dr. Anwar Moh Yusof. Time is yours.
Assalamualaikum. Can I share my slides first?
Okay.
Yeah.
Please give the Professor Anwar to share a slide.
Okay, everyone can see the slides?
Yes, we can see.
Yeah, wait a second. Okay. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to everyone. Thank you, moderator, Dr. Rama Muhammadani, Honorable Vice President from STKP PGRI Sumatera Barat, and Mulia Suryati is a chairman for the conference from the program study Pendidikan Matematika STKP PGRI Sumatera Barat. Thank you for inviting me for such excellent program for today. So the conference name International Conference on Mathematics and Mathematics Educations 2021. So the title I would like to share today is focusing more to integrate for the second and also the third, the second and the third keynote. We talk about the online learning, what type of pedagogy, and we talk about how to persuade the student. And the title is the edutainment technology during the new norm era by adapting no learn use strategy in massive open online course, which is the MOOC. So I think I will share a bit from the Malaysian experience and also from your University Malaysia Kelantan. Okay, let me show you first. So just to introduce myself, I have a QR code you can scan over there. So easy to really communicate with me after this. So the UMK actually is located in the East Coast Peninsula of Malaysia. In the state of Kelantan, you can see the map over there. So it's a near border to the Thailand, so that the Patani is not that far from us, from me. So we have 3 campuses, and we have a UMK in Bachok, Kelantan, Pengkalan Cepa, and also Jeli. All the campuses is located in the state of Kelantan, Malaysia. So I'm working as Faculty of Creative Technology and Heritage since 2008. We go to the next. So for the next slide, here I would like to show you the table of content for my sharing. So I will share about the objective, overview, and focus on innovation, rational innovation approach, student involvement, and also impact based on my based the experience in Malaysia. So first, in the end of my session, the audience will be able to really identify the rationale in the innovation approach, student engagement, and also innovation impact through the alternative assessment approach with know, learn, and use strategy. So let me promote a bit. So in the University Malaysia Kelantan, we have a platform. We call that as a MOOC UMK. So the MOOC UMK that I will show the definition of the Malaysia Open Online course is totally a free online course that we have a platform that use 100% online. So the issue that we face in terms of how we can persuade the student, how to engage it, how to make sure that the student able to complete the first task and continue to the another task. So we have the platform that allow for this platform, the platform is allow the student to collaborate with other people, which is the external student in outside the campus. So it's a good the good platform that the student able to gain the knowledge from the outside, from the other learner from the outside the campus. So before when we talk about this kind of overview, we talk about the Industrial Revolution 4.0, how the announcement give to the benefit and change the paradigm in terms of the education parts. So we can see from the 5 years ago, the revolution is introduced by Prof. Klaus, that mentioned in the World Economic Forum's annual meeting 2016. So from the share about this Industrial Revolution 4.0, we can see that in the Industrial 4.0, it showed that the cyber physical system, IoT, and also network were highlighted. So we need to ensure, we need to really know our student that we want to what we call as give the in the end of the program. So how the student will be change their mind in terms of that. Okay, so I show you for these other technology embed in the new paradigm, and the people starting to explore and implement in the era in this area. So in the education sector, as the educator, okay, the technology is also need to adapt, to infuse, and also integrate to ensure that the knowledge and skill will be aligned together. So they will talk about the constructive alignment on that. So how do so? So to prepare this, I would like to share the experience from one of pedagogical model, which is might be help educator to design the course that integrate the edutainment design in knowledge, learn and use strategy. Okay, in Malaysia, okay, the government had aligned turning the benchmark to the industrial needs 4.0. We structured the policy. So in the learning environment, to ensure that policy of education able to match. So they have 11 shift of Malaysian student standard system. So they have 3 shift of the higher education, higher education. So I show here. So we already have implemented the policy from in terms of the blueprint of Malaysian Malaysian education. So here I would like to show you the 11 shift of Malaysian standard system. I focus on this. Okay, and also I would like to recall that as a plan, the blueprint, so which is the turning benchmark to the industrial need in 4.0. Okay, so I'll go back here. So you can see here from this policy, they have a key factor that ensure that implementation of ICT in education can be implemented with these 3 C. So you can see that 3 C, okay. The 3 C: content, connection, confidence. From this diagram, the connection with a teacher and also a student can able with the clue, learn and use strategies. So I show you, so what is a know, learn, use strategy I talk about. So the based on the philosophy behind the KLU strategy. So module 1, okay, you can see here, there are 2 indicators in terms of level of challenge and also level of competence. So based on this level, we have the ZPT in the beginning. So the flow to make sure that we integrate with the know, learn and use. And for example, when we want to create the module in the online, we want to make sure that the module 1 have that level that if the module 1 is too hard, okay, the student easily get anxiety and because they're not able to learn it. So because the competence will be low, so the student easily get bored if the challenge is in the module is too easy. So next, I would like to share you one of the pedagogical model called that as a E-Project BL or E-Project-based learning, which is help to maintain the ZPT in online course. So I have a 4 chapter on that. So I shared about the innovation of rational. So in the innovation, refer to the diagram in conceptual model that I showed before. The rationale will be defined based on issue to implement this innovation. So you can read a bit about the issue that the alternative approach during the pandemic is one of major when we try to implement the approach that mostly after we have facing the pandemic pandemic right now. So and second one is to address the issue that teaching staff need to meet the additional needs of over means that the number of students is too many. The limited skill that teaching staff in terms of knowledge related to the technology are too fast, and the time constraint and place for the student consultation. And the last one is offering different courses using the same skill set. Okay, so based on the rationale in the student and also educator and teacher, so you can see in the student meet the needs of active involvement of student virtual immersive. Second one is manage the personalized learning through the virtual immersive. The third one is a student skill and knowledge occur through the incremental digestive information. So for the teacher, that based on a rationale that manage the teacher able to manage a lot of classes through the virtual immersive, use the latest teaching tools 2.0 communication applications, provide feedback to the student stage according to suitable level of competency and intelligent diversity. So we focus on the multiple intelligence. So in chapter 2, they focus on innovation approach. So in the innovation approach, I give some one of the, based on the sample of one of skill-based MOOC, which is in the name of that MOOC is penghasilan poster menggunakan Adobe Photoshop. So this MOOC courses integration, so they integrate between the MOOC course consists of theory-based MOOC and also skill-based MOOC. So based on the conceptual relationship, so all these module or the MOOC, it becomes the object learning, and they have show here the relationship between the theory and also skill-based MOOC. So we have in theory-based MOOC, we have computer and arts. Computer, these are the courses, courses, computer graphic, 2D, multimedia technology in museum. So you can see the skill-based MOOC is how to create a poster using Photoshop and how to create a video using the Premiere Pro. So for the chapter 3, so I would like to share how the student involvement through this. Okay. So this one of the student involvement in terms of the cognitive domains that use the mind map activities. Okay, the student involvement in psychomotor, I'm not sure why they're not all. Okay, I have a screen here. So actually what I would like to share here, okay, they are through creating the animation presentation to stimulate the psychomotor domain to understand the concept. And the last one, last one is creating poster to disseminate the information to others, to peer and also the teacher. So this one is the sample, and this one is focused to capture the affective domain. After that, based on the student involvement from the reflection, we get the student feedback from this. So after we end of each module, okay, we have another section which is we call that as a reflection among the student. So the student will be share which part is blur, which part is more is they really understand most in that module, the first module. So from there we can know whether the most majority student able to really understand the module, or we can do the intervention to improve the understanding of student. Okay, if we use the MOOC, the good thing is we can able to monitor the monitoring part, which monitor the student performance with a MOOC platform. From here, for each module that we are developing, we can really know the how many, we call the SLT. SLT is student learning times to complete each module. So easy for us to really know, okay, for the best student, how many times they need to allocate to complete their task. So this one is very good to monitor the student. I would like to show you that the triangulation assessment approach, we call the alternative assessment approach, that combined with the self-assessment, peer assessment, and also the continuous assessment in the online module. So in the end, we can capture the student competency through this. So basically, in impact, in chapter 4, I would like to show you that from the 10 skill of 2025, here, actually, from our activity, actually, they were able to map and we able to prepare skill that support Industrial Revolution 4.0. So how the impact in terms of conventional techniques and alternative techniques. So you can see in the conventional techniques, scale costs we thought over and over again, and a different theoretical cost. So the second one is face-to-face course learning and conventional. The skill on each course are updated and separately. The assessment is conducive manner. Student motivation is hard to measure. And for the alternative techniques, that the integration techniques of theory course and also skill course. So they have a virtual skill course learning. The content is of the skill course is always improved without changing the without improve to sustainability of the theory course. And fourth, the continuous assessment and peer assessment as self-assessment and applied. And student motivation is measured through the edutainment technology, the edutainment approach. So basically, I have do a very simple, just a simple study to compare based on the three groups from the course with a total population of 303 students. Based on the quiz number 1 is conventional techniques, and quiz number 2 is alternative techniques. And the impact of this project, the student result and the result of the theory courses, it shows here, the diagram. And also the part of the example for the year 1 student works. After they go and follow and after they complete all the module in the MOOC. So this is the part of the achievement. And lastly, before I end, so I would like to conclude the presentation by this statement. Computer technology is not longer as an accessory, but has become the necessity in the visual learning. So before I forget, I would like to just to share you that we in the University Malaysia Kelantan we have this book, italic book series. Inside they have a lot of how to focus on the when we have the pandemic. So we have a lot of reference we collect from the all lecturer from all around in Malaysia, and we collect and book the book series. So I think that's all. Terima kasih.
Sama-sama, Professor. Thank you for your lecture today. Later, we will have a discussion part for you after the Miss Delcy ICoMMSd gives us lecture. Now, it's turn from our fifth keynote speaker, Professor Delcy ICoMMSd. Okay, I will read the CV of the Miss Delcy. So this is the special keynote speaker because she is here with us, because she is our lecturer and she is also our faculty member in STKIP PGRI West Sumatra, and her background study master and PhD in Bandung Technology Institute, and then academic position as the Department of Mathematics lecturer and researcher in the Department of Mathematics Education. And recent publication on 2019 about the effective of guide discovery based module, a case study in Padang City, and then modul herediter atas aljabar lintasan Leavitt dari graf A, and then another research published in international and national journal. Now, time for Miss Delcy to give speech. For the Miss Delcy, stage is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity, Bapak Ramadoni as moderator. And I would like to thank the organizing committee for giving me the opportunity giving the talk in this conference. Let me share my slide of presentation. Okay. I would like to talk about the EU projective resolution of simple module of a Leavitt path algebra. Based on joint work with Irawati and Intan Muhtadi Alamsyah. This is my outline of talk. Some basic definition. Leavitt path algebra, simple module of a Leavitt path algebra, the EU projective resolution of a module, and the last one is the main result in our research, algebra. A directed graph E consists of a set E0 of vertices and a set E1 of edges or arrow and maps are S from E1 to E0. For each E, SE is the source of E and RE is the rank of E. If SE equals phi and RE equals W, then also say that phi emits E and W receive E. A vertex phi is called async if it emits no edges. In this example, RE is an async. This is async. An infinite emitter is a vertex which emits infinite many edges. We can see like this. Phi is an infinite emitter. Emit infinite many edges. And for E is in E1, we call E star equals H. A path mu of length n greater than 0 is a finite sequence of edges. Mu equals E1, E2 until En with R EI equals S EI plus 1 for all E equal 1 until N minus 1. Leavitt path algebra was introduced by Abram and Arandapino in 2005. This is the definition of Leavitt path algebra. Let E be an arbitrary graph and K any field. The Leavitt path algebra LKE is defined to be the K algebra generated by a set phi together with a set of symbol E star where E is in E1, which satisfies the following relation. There are 5 relation. The first one, Vi Vj equals delta Ej Vi for all Vi Vj is in E0. Here, the function of delta Ej equal 0. Equal 1 if E equals J and equal 0 if E doesn't equal J. And the second relation, SEE and ERE equals ERE equals E for all E is in E1. And the third relation, REE E star equals E star SE E star equals E star. We can see this is E, this is E star SE and RE. We can see SE equals ERE equals E and RE E star equals E star SE. And the fourth relation, the relation CK1, E star F equals function delta EF RE for all EF is in E1. And the last relation, relation CK2, phi equals the summation E star for E is in E1, where SE equals phi for every phi is in E0, for which the cardinality S inverse phi is finite. And then Chen in 2012 constructed simple module over Leavitt path algebra, namely module VP and module NW. Let P is equals E1, E2, E3, and so on be infinite paths in E, where EI is in E1, for all E is in N, and for which SEI plus 1 equals REI, for E is in N. We denote the set of infinite paths in E by E infinite. For P is E1, for P is in E infinite, and E is N, we denote tau less than N equal N of P equals E1, E2 until En, and tau greater than N of P equals En plus 1, En plus 2, and so on. And we, if we have P key is in E infinite, P equivalent key if and only if tau greater than M of P equal tau greater than N of key for Mn is in N. This relation is an equivalence relation on E infinite, and the equivalent class containing the path P is denoted by a P. We read the class equivalent of P. Let's see a cross path in E. The path C, and so on is an infinite path in E, denoted by C infinite. P is in E infinite is called rational in case P equivalent C infinite for some cross path C. And if P is in E infinite, is not rational, we say P is irrational. Chen give the definition of module VP. Let P be an infinite path in graph E, and let K be any field. Let VP denote the K vector space having basis a class equivalent P of P that is consisting of element of E infinite which are equivalent to P. For any V is in E0, E is in E1, and K is in a class equivalent of P, define V time K like this, and E time K like this, E is star time K like this. Then the linear extension to all VP of this action, and those of VP with the structure of LKE module. And Chen give a theorem about module VP. Let E be a graph and K in E field. Let P is in E infinite. Then the LKE module VP described in definition 2 in this definition is simple. And the next simple module introduced by Chen in 2012, module NW. Let W be a thing in E and K in E field. Let NW denote K vector space having basis beta equals the set of P where P pass with RP equals W. For V is in E0, E is in E1, and P is in beta, and thing W we define V time P like this, E time P like this, and E star P like this, and E star time W equals 0 for all E is in E0. Then the K linear extension to all NW of this action, and those NW with the structure LKE module. And Chen give a theorem about module NW. Let E be any graph and K any field. Let P is in E infinite. Then LKE module NW described in definition 4 is simple. And the next theorem, let E be any graph. Let V be a line point with N W. V line point like this. This is a V line point, maybe like this. This the path, the line, the path ending W. V, this is a point of V. V is called line point. let E be any graph, let B phi be a line point with n W, then LKE phi module LKE phi is isomorphic to module n W. For anything W, ideal LKE W of LKE is found by path in E ending W. Moreover, for any E is in N, we get that VI equals WI equals W, and thus we consider V equals W infinite as an element in E infinite. For this reason, for anything W of E, we refer to NW equals LKE W as chain simple module, and for consistency, we denote NW by phi W infinite. And this is the notion of the U projective resolution of a module. Given a module M, there exists a projective resolution of M, i.e. an exact sequence like this, where Pi, P0, P1, P2, and so on are projective. If we replace exactness with U exactness, then we have the U projective resolution. The construction of U projective resolution can be seen in Mahatma and Muqtadi Alamshah in 2017. The U projective resolution of a module M is a U exact sequence like this, where Pi, P0, P1, P2, and so on are projective, and which is Ui-1 exact at Pi, i.e. Di plus 1 of Pi plus 1 equals Di of Ui minus 1 for I equals 1, 2, 3, and so on, where Ui-1 is submodule of Mi-1. And for non-projective module M, non-projective module over hereditary algebra, the resolution will be as follow. This resolution, this is module non-projective module M. This is P projective, D inverse U also projective, D inverse U also projective, kernel D also projective. U submodule of M, the inverse U submodule of P, kernel D is submodule of the inverse U. When M equal U, or if we take the submodule of M is M itself, so D inverse U equals P. And we have the following theorem. Let A be hereditary algebra and M be a simple A module. Let M equal U, or we take the submodule of M is M itself. The U projective resolution of module M is like this. Equation 2. This is non-projective module, projective module, and this is module 0. And remark, Leavitt path algebra is hereditary algebra. So this resolution we use the resolution for Leavitt path algebra because Leavitt path algebra is hereditary algebra. And this is the main result in our research. The U projective resolution of a simple module over Leavitt path algebra. The first theorem, let E be any graph, let C be a simple cross path in E with phi is equals SC. Then the following is the U projective resolution of simple module phi C infinite. We can see this is actually one line. And we can see the first line or the first row is a continuation of the second row. This is the simple module overlay fit path algebra VC infinite and module projective module. And we can see the sketch of proof of theorem. Phi is in LKE is idempotent. So module LKE phi is projective. And we have proof rho C infinite from LKE phi to phi infinite surjective. And we have proof kernel rho C infinite equal LKE C minus phi. And by using by using equation 2, this equation, we get the equation 3, this equation. And the second theorem, our main result, let E be any graph, let C be a simple cross path or async in E with phi equal SC, let alpha equals E1, E2 until En be any path in E for which no vertex of alpha is infinite emitter and for which R alpha equal REN equals phi, let U equal S alpha equals SE1. Then the following is the U projective resolution of chain simple module VC infinite. As previous, it is only one row or one line. The first row or the first line is a continuation of the second row or second line. This is the simple module VC infinite. This is projective module. And we can see the catch of proof. U equals, this is SE1. U equals E1, not EI, E1. L is in LKE is idempotent element in LKE. So module LKEU is projective. We have proof that rho alpha C infinite from LKEU to VC infinite surjective. And we have proof rho alpha C infinite equals LKE alpha C alpha minus U. And by using equation 2, we get the equation 4. This is equation 4. And the last theorem, the last result in our research, let E be any graph, let P is in E infinite, be an irrational infinite path in E, for which no vertex of P is an infinite emitter and P equals SP. Then the following is the projective resolution of the chain simple module LKE module, the chain simple LKE module VP. As previously, it is only one row. The first row is a continuation of the second row. This is the simple module of VP. This is projective module. And we can see the catch of proof of that theorem. Phi is in LKE is idempotent element. So module LKE phi is projective. We have proof the map rho P from LKE phi to VP surjective. And we have proof kernel rho P equals direct summon GIP from E equals 0 to infinite. Then by using lemma 219 in Abram et al. In 2015, GI of P is projective. And then by using equation 2, we get the equation 5. Equation 5, this is equation 5. This is the reference in our research. And thank you for your attention.
Okay, thank you for the Miss Delcy. Please, camera. Okay, that's all about the lecture from the Mr. Anwar and Miss Delcy. Now times for us to discussion part for 20 minutes. If you have question, please raise your hand. Di partisipan. Okay, please, for all of participants, if you have question, please give your question. And then you can ask in bahasa. Jika ada pertanyaan juga bisa bertanya dengan menggunakan bahasa Indonesia.
Boleh ini bahasa. Sedang.
Before we are waiting for other question from the participant, Professor, I have question for you. This is related to you have triangulation for assessment, right? And then I saw in your slide you have the self assessment, peer assessment, and then continuous assessment. Maybe we are familiar with self-assessment and peer assessment, but for the continuous assessment, we don't have any knowledge much about this. Could you please to explain more about this assessment? Thank you.
Okay, good. Thank you very much. Thank you for the question. It's a very interesting question regarding the continuous assessment. So actually, the continuous assessment is basically in the online course. Normally, it's it not just apply for the online course, but however, it also apply for the normal parts. It's the way how you try to triangulate, how you can able to connect between the first module to the second module assessment, and the mark is keep continuous addition, and also from there the student if they already complete, for example, for module 1 they completed it and they have the assessment on that, so the mark for the first module will be carried out to another module. So they have that kind of approach in the online course. Similar in the normal part. For example, we have a class. I give the scenario in the class. So for this week, I have covered for example, module 1. So in the end of module 1, actually, we have already based on the project-based approach. Okay, we have decided to have, for example, one project related for what I give example like script. The student needs to complete a script and storyboard. So the first module 1, they need to really know what is the type of learning linear and also non-linear storytelling. So we have already after the first module, okay. In the end of that module, the student need to complete one assessment. The assessment is like I show you. If we want to make map the student cognitive domain. We already know about cognitive domain. Then normally in mathematics, we capture in the cognitive domain. So in the cognitive domain, part of student knowledge in terms of they able to compare between the linear and non-linear storytelling. So from there, they capture a small portion of marks over there. Okay, go to the next. go to the next module. After the next module, they apply using the what they answer from the previous module and applied it to continue for the next module. For example, like we want to build a house. So the first module, they will be captured in terms of plan. So plan, we already give the marks from that. And after that, in the second module, okay, we use the same plan that they have give, and they continue. For example, after that, they need to design it. And after that, in the end of the module, they complete the whole house. For example, I give the analogy on that. That's the beauty of the continuous assessment.
Okay, I got it, Professor. So it's based on
Okay.
a model, right? So
Yes,
one more thing about because you develop and design of the KLU strategy, right? Non-learn
Yes.
and use. And then, as we know that in mathematics, we can apply for the non and learn, but it's quite difficult for us to use for this step. So especially for us in college, because we only have 3 credit course. For example, I'm teaching in calculus differential course. So how can we use this third stage to implement
Okay,
our
good.
classroom? Okay, thank you.
That's a good question. You know, okay, I would like to give some experience, which is what our Malaysian blueprint, and they in the high education we call that as sulam. Sulam is something the experiential learning, which the student able to teach others. Remember, I told you that they have a collaborate with the internal and the external. Okay, in the end, the student able to teach the learner from the external. That's the beauty of when we apply that for the use strategy. So for the mathematic scenario, they can adapt actually. For example, I give a very simple in terms of mathematics. Once the student already know the concept through the know strategy, they have learning. Learning is something more we can do a lot of entertainment, maybe the repetition in terms of games, maybe we put some any kind of learning approach to that. After they already know the concept, know how to use it, how to they learn it, they start to develop their own scenario and share to others to complete the scenario. For example, they know how to 2 plus 2 equal to 4. For example, I just a very simple. And then they are okay from the learn strategy. Okay, they know how the function of 2 is number, equal is something like they already know how the function works. That datang is came from the learning strategy. How to use it? So it start. Okay, I already know the concept. So what I'm to do, I become an instructor. The student become the instructor and give the scenario to others. So I have 3 apples. I have another 2 orange. So how many fruits I have? So actually, the type of that is not what we call the instruction is not come from the teacher, but it's come from the student. But student teach to other student. That's the part of concept use. That's a good. Dia macam similar like kita beramal lah, kan? Kita berilmu, kan? Kita belajar dan kita amalkan. So when we say the amal means that we try to apply it. Kita usekan benda tu. Itu the beauty of this edutainment design.
Okay, thank you, Professor.
Okay.
Actually, I have a lot of questions for you, but because we also want to another participant to ask. Okay.
Okay, it's a good. Okay.
Please, for all our participants, if you have question, please raise your hand. Is there any participant raise hand? No? Okay, if no, I will like to ask one question for the Ms. Delcy. Okay, special. This is not related with your dissertation. Before that, I would like to explain what the Ms. Delcy explained about her dissertation, and then she found first serums. So I know that it's not easy to find the serum. So could you explain for us your experience to find it? Thank you.
Yeah, for me, it is also difficult to explore or develop a notion or an idea to get a theorem. I have many time to get the theorem. I have read a lot of paper related to this notion, and I joined the seminar from expert. I joined the international conference. I go to abroad to come to expert to learn or study the topic, and it is only a little result, and for me for to resolve one paper for me is difficult, and I have two paper selama as long PhD. Yeah.
Thank you, Ms. Delcy, for your experience. Okay, the last question, is there any question from other participants? Please raise your hand. Jika masih ada pertanyaan, silahkan diangkat tangannya ya. We give a second. Oke, kita beri beberapa detik. Masih ada yang mau bertanya, silahkan. None of one. Okay, if no people would like to ask a question, maybe you can contact a keynote speaker after this conference to ask any question you want. Okay. After this one, we would like to give a certificate for both of keynote speakers. The first for the Dr. Anwar bin Moh Yusuf. Give applause for him. Thank you, Professor Anwar bin Moh Yusuf. And next for Dr. Delcy ICoMMSd. Please receive our certificate. Thank you for your willingness, and then give applause. Okay, that's all our keynote speaker talk today. We know that we have learned a lot today. However, we have limited time. Thus, we have to close this session. Sorry. Thank you for your thank you for your time. Thanks for all keynote speaker, presenter, and participants. The last but not least, see you next year. Assalamualaikum warahmatullahi wabarakatuh. I give back to the MC.
Okay, thank you to our moderator, Mr. Ramadoni, MPD, PhD.
Terima kasih kami ucapkan kepada Bapak Ramadoni, MPD, PhD.
Ladies and gentlemen, it's time for us to end this session. Thank you all for your attention and cooperation. We apologize for all the shortcomings. Hopefully, the knowledge we get today is useful in our lifetime.
Itulah pemaparan materi dari narasumber kita pada pertemuan kali ini. Semoga ilmu yang kita dapat hari ini dapat bermanfaat untuk kita ke depannya. Terima kasih atas perhatian. Mohon maaf atas kekurangan. Assalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, may I have your attention for a second? The parallel session of the first international conference on mathematics and mathematics education, ICoMMSd 2021, organized by the Mathematics Education Department, STKIP PGRI Sumatera Barat. And the parallel session will begin on 1:30 p.m. Okay, 1:30 p.m. And
sedikit informasi untuk sesi paralel International Conference on Mathematics and Mathematics Education ICoMMSd 2021 akan dimulai pada pukul 13.30 waktu Indonesia Barat. Sekali lagi kita beritahu akan dimulai pada pukul 13.30 waktu Indonesia Barat.
Yes, and the parallel session began 1:30 p.m. and you will see about your room meeting and schedule on your device here. Please to ICT to show the room for parallel session.
Berikut kami tampilkan nama-nama pemakalah beserta room pada screen Zoom meeting. Diharapkan kepada presenter untuk bergabung pada break room, tepat waktu dan sesuai dengan room yang telah ditetapkan. Nanti akan dibagikan melalui screen Zoom meeting. Silahkan, bisa ditampilkan.
We hopefully you'll attend on Zoom meeting on schedule and do not be late. Thank you.
Okay.
Okay, so this is for room 1 or the first room about mathematics field, and the moderator is Mrs. Hamdunah MSI.
Ini adalah kelas atau room 1 untuk matematik dan dimoderatori oleh Ibu Hamdunah MSI.
The second room, that's about mathematics field, and the moderator is Mrs. Ainil Mardiah MSI.
Berikut ruang kedua atau room kedua yang akan dimoderatori oleh Ibu Ainil Mardiah MSI.
The third room, this is about mathematics education field, and the moderator is Luki Herianti Jufri SSC MPD.
Berikut adalah room ketiga, yaitu Pendidikan Matematika yang akan dimoderatori oleh Ibu Luki Herianti Jufri SSI MPD.
The fourth room, it's about mathematics education field, and moderator is Dr. Ramadoni MPD.
Berikut room keempat yang akan dimoderatori oleh Bapak Dr. Ramadoni MPD.
Okay, the fifth room, it's about mathematics education field, and the moderator is Mrs. Julia Haryono SSI MPD.
Room kelima yang akan dimoderatori oleh Ibu Yulia Haryono SSI MPD.
the 6th room about mathematics education, and the moderator is Dr. Ana Cesaria, MPD.
Room ke-6 yang akan dimoderatori oleh Ibu Dr. Ana Cesaria, MPD.
The 7th room, it's about mathematics education field, and moderator is Ibu Hafizah Deliana, MPD.
Room ke-7 akan dimoderatori oleh Ibu Hafizah Deliana, MPD.
The 8th room, it's about mathematics education field, and the moderator is Mrs. Audra Pramita Muslim, MPD.
Di room ke-8 akan dimoderatori oleh Ibu Audra Pramita Muslim, MPD.
The 9th room, it's about mathematics education field, and moderator is Mrs. Alfi Yunita, MPD.
Pada room 9 akan dimoderatori oleh Ibu Alfi Yunita, MPD.
And the 10th room is about mathematics education field, and the moderator is Mrs. Melissa, MPD.
Dan pada room terakhir kita, yaitu room 10, akan dimoderatori oleh Ibu Melisa, MPD.
Okay. Okay, ladies and gentlemen, it's over for this session, and you will join us to another session or next session at 1:30 p.m.
Sekali lagi kita ingatkan kepada seluruh peserta untuk sesi paralel agar tepat waktu dan akan dimulai pada pukul 13.30 waktu Indonesia Barat.
Okay, dear ladies and gentlemen, before we go to break time, please turn on your camera because we will capture your photos on Zoom meeting.
Pada waktu break ini, kita informasikan kepada seluruh peserta seminar internasional program studi pendidikan matematika agar menghidupkan kameranya, karena kita akan mengambil sesi foto bersama. Terima kasih.
Okay, are you ready?
Silakan yang belum menghidupkan kamera agar
Please
menghidupkan
turn
kamera.
on your camera. Ladies and gentlemen, please turn on your camera because we will capture your photos on Zoom meeting.
Silakan menghidupkan kameranya karena kita akan mengambil foto bersama pada sesi Zoom meeting kali ini. Terima kasih.
Okay, let we start with the first scene.
Kita mulai pada halaman pertama.
1, 2, 3. Okay. The second scene.
Selanjutnya halaman kedua. Silakan yang belum menghidupkan foto videonya, silakan hidupkan kameranya terlebih dahulu untuk melihat videonya. Terima kasih.
Okay, thank you. The third scene.
Selanjutnya halaman ketiga.
Ladies and gentlemen, please turn on your camera because we will capture your photos on Zoom meeting.
Silahkan hidupkan kameranya, sekali lagi kita beritahu, agar dapat kita ambil fotonya pada screen Zoom meeting.
Okay, thank you. And this is the final for this session, and see you to the next session on 1:30 p.m. See you later. Bye-bye. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.